So hello guys, hello everyone. I'd like to welcome you here at this Friday's lesson, Friday session, our elective course. So we just went through some data structures and data types and some let's say like more basic and more advanced kind of this stuff during the previous two sessions. So at this moment, I presume that you are able to understand some things like, let's say, what are the useful and basic data types like numerical values or chart values, logical values, or some special kind of values like not available values, not numbers, null objects, and so on. And also some basic data structures, especially vectors, which are just one-dimensional sequences, ordered sequences, sorted sequences of one data type values. So it could be a vector of one or more, for example, characters, or vector of one or more, let's say numeric numbers, integer numbers, whatever. Also, we just talked about some advanced structures or two-dimensional structures like matrices and data frames. Both of them are very important, very useful and important for data analysis. Whereas the matrices are, in fact, for example, like many vectors combined, for example, such that they could be aligned between themselves and create like a two-dimensional object. So each columns of one matrix contain only values of one data type. Similarly, each rows contain only one data type values. It means that each values of one given matrix follows only one data type. So it could be a matrix. We can say that we can have a matrix of numerical values or integer values. Because are these ones which are very, very similar to real numbers or float numbers, let's say, decimal numbers. Matrix which consists only of an integer and so on. So logical values, characters, special values like not available values and a values, So and this was for matrices. If we are talking about data frames are a bit different, and as I told you, data frames are let's say pretty close is the way of thinking about real world data. If we are just trying to collect some real world data. Usually we got more than one variables. These variables are arranged into columns. If you are talking about the two-dimensional structure, and it means that the columns could be called also variables. And in rows, each one of the rows stands for one observation. Yeah? And this is pretty the way of thinking, or is pretty closer to way how we like to have a real data or how we treat real data, because you know that in real data we can call it, for example, some continuous numerical values like human heights or body weights, some blood parameters like glycemia or whatever, some other like clinical biometric, for example, values, variables like BMI index or whatever. And also we can include some categorical kind of data, variables like, for example, typically gender. Usually there are only two values like males and females, and it's like maybe a kind of bigger thing of a world. Yeah, it's a very important, big question, big topic of nowadays, But understanding the issue, if you are talking about R and about data analysis, usually we consider the variable gender only to have only two categories, two levels, males and females. Well, so this is the way how this is the way how this is the stuff that we went through during the last two previous lessons. We also mentioned something about the list. The lists are kind of special. Two-dimensional object. It is in fact two-dimensional, but you know that I tried to explain you to that there's something like bit different considering of the dimensions, because there is rather two different kind of arrangements of data. The first first level arrangement is just in arranging the slots of the list, and the second level of arrangement in list is that each slot of the given list could contain a different individual data structure, like matrix or data frames or list itself. It could be a list and list and list, and just kind of recursion it could be. And so it means that the first level data arrangement is just vectorized, just a linear arrangement. And the second, it could be also linear if there is a vector, or it could be two-dimensional if there is a data frame or matrix, and so and so. So honestly, the dimensionality of a list is could be approximately higher than two. There are, for example, many data frames in one list, since we know that data frames itself have two dimensions, and list itself has one dimension per sorting or ordering of the slots. Means that the dimensionality is somewhere between 2 to 3. There is also mixing of vectors and data frames in one list. So this is important things to know about before we start today's topics. I think today's topics are like more dynamic, or how to say, because since we talked about some relatively static attributes, static features of data during the previous two previous lessons, we are going to talk about some more dynamic stuff. Let's say. I mean, just that we are going to talk about for today about cycles, about loops, about some if statements. So, for example, if you took some basic programming courses for your high school studies, this will be very similar to stuff you went through during these courses, like some CS 101, I don't know what it's called, like computer science 101, this very introductory course in informatics and computer science, where some basic programming stuff is usually taught, like for loop and while loop, what is if statement. So this is the stuff we are going to go through for today, definitely, and taking into account the fact that we are going to implement this stuff in R. But the logic of the loops and the statements on it's pretty similar to all procedural languages like Pascal, or I don't know, Pascal or Python or whatever is now used to be a teaching language for programming courses. Well, so before this, there is also one important part I would like to go through, and this is just data import and export within our language, our environment. So we are going to talk about some ways how to import some files, usually, for example, CSV, like comma separated files, comma separated values files into R. So from, for example, local drive, or for some web URL, web address to your currently running R session. And in a positive way, but similarly, we are also to talk about some exportation. So to export, for example, an R structure, R object, which is of your interest, for example, some table with some interesting values, for example, agglomerative values about some data frames, which we use for the seminar project, or for some, for example, paper, manuscript, whatever you want, whatever you want to say again. So we are going to how to export this from R, because if it's in only R, it's going to be lost once we are going to just to break your session. You're going to shut down your session, because it's like dynamic object in your random access memory. Yeah? So we have to save it for the local drive or somewhere to cloud, whatever, just to make it, for example, shareable, just to make it I don't know, editable without using R. Yeah. So that's the way. This is very important. This is also a topic which is a bit closer to a real data analysis. So we are just slowly moving towards real and applied data analysis. And the growth of this will be like next week, where we are going to start some additional functions and some data exploratory analysis. So EDA, it means that if you have some real world data or whatever data, which are interesting, but for the very first, in the very beginning, you know almost nothing about the data. Yeah, but you would like to know anything, something about the data. You would like to know something about some mutual relations of the variables which are included in the data set. There's a way how to do it. It's usually based on some graphical visualization because we are just trying to, in an exhaustive way, to plot all pairwise two-dimensional possible relations, associations. And so by this, we are going to do something like, let's say, plot matrices, yeah, something like this. So it really, I think, interesting. It could be done using only a few commands, so it's nothing too difficult to do it now. But it's very powerful, yeah, because from the point where you know nothing about the data, you are just very quickly moving to point where you know anything or something significant about data, something which could be more interesting, which you should maybe go more deeper into. Yeah, so that's really interesting. So this is what we are going to start the next week with. But for today, let's start. Yeah, and the rest of the next week will be about some basic statistics like inference test, inference thing about modeling like linear regression models, and also some classification modeling like logis regression. So I think interesting stuff which can be done using Microsoft Excel. This is why we all do this, because R is something which should be much more powerful than Excel. So I'm just slowly moving to the state you are going also to understand that, yeah, this is pretty easily done, or this could be done in R. I can do it, for example, after some time, after some handling with some my code, after handling with my errors. Okay, that's pretty natural for a newbies in R. But I know that if I just try to do it in a Microsoft Excel, it will be really, really painful because, yeah, because for example, to do some plots, yeah, this is also stuff we are going to do. Some plotting to make some plots which are pretty usable as a camera-ready version, for example, to journal papers or to similar projects. Definitely, I'm going to do some similar projects, for example, in the third year of study to immunology. There's something like a similar project. You are supposed to go through some literature, some references, extract some piece of information about a given topic of immunology, and maybe to make some, I don't know, quick insight using, for example, some data which are publicly available. So R is, I guess, a tool you can feel free to use for it. Yeah, it could be done using R. Okay, so for today, call for some license agreement, something like this. So we're going to start with the data import and export. And saying this, the absolutely crucial term we should know about is a working directory, because once you are trying to get something from your local drive to our session, it's more than important to know where is your current working directory set, because current working directory is pretty the part of your local drive, usually local drive, or usually local drive or external drive, where R is able to pick or grab all the folders or all the files if possible or if needed, and extract the data, and use the data within the R session. But it's very handy to know where the working directory is. So how to extract the path to your working directory is important. Or how to, for example, change the path, how to make for example, a newly created folder with a new download data as your working directory to make for your current R session possible, just to upload this data into currently running R session. So working directory, the first time of this, and then we will try to go through some typical cases of data like CSV, Excel files, plain text, maybe some URLs, some kind of web HTML, formatting of Excel, in fact very similar to formatting of Word, and to some maybe kind of bit special formats like plain text as a console output, LaTeX text, and some exotic formats like, for example, prefabricated files from different clickable statistical softwares, like for example SPSS, and so this is prepared for you also in the script, and then we'll move towards maybe even the most important interesting stuff, or at least I hope it feels a bit interesting. The conditionals, loops, warnings are so in general this is called like usually uh, flow control features for flow control constructs, things like this. So how to, for example, make a procedures or even implementing of a inbuilt or user-defined functions to proceed to just to proceed your data to some, I don't know, some desired state, which is like for example rectangular and smooth data, which could be pretty used as an input, for example, some advanced function like for building linear models and so on. Okay, so this is like a today's plan, what we should do. And the working directory, as I told you, essential term you should know about. I'm just running one R session here in my R studio. This is like the script we are using, so you know it's still the same. Underscore 0 for today. Underscore 03 underscore script underscore dot and R suffix. So this is what is going to be. It's already shared on GitHub, so you can take a look at this. So the first bunch of code is related to working directory. So if I would like to know where is my current working directory, I can use quick command get wd and round brackets without any argument. And get wd is just the abbreviation for get working directory. Yeah, it's easily to remember. Get working directory. So let's run it. And it's just a path. And since I'm just running my application on Windows, Windows, it's in Windows notation, but it's usually on C disk. But yeah, in documents, in some folders and subfolders dedicated to this elective subject. But the rule is, and this is important to know, or this is handy to know, that the rule is if you have a, let's say, folder where you have your script, which you just can run in RStudio, so you can see that usually R scripts usually have this kind of icon like a sky blue round, and it is a white R written in the center of this round. So you can simply click on it, and it's going to be open in RStudio. And by doing this, if you are going to start your script by doing this, it's easy, or the RStudio is able to, let's say, decide or is going to realize from which folder you have started your R script, and this folder is by default set as your working directory. And this is it, because you know it is just the last folder is academic year 2092-20, short for my version of the course with some underscores. And this is pretty my working directory, and this is this is just a folder where I have my script is currently running in our session. So at the beginning of this session, just click on this. I just click on this. It was open here, and by the default manner, by the behavior of RStudio, this was by default set as a working directory. So not a big deal. It could be it's usually done automatically in a way which is maybe the most comfortable for many end user. But yeah, this is the way how we can check if really our working directory is D1 from where the running script, current running script was started. The next command is there, and there is no argument within the round brackets. So if I'm going to I'm sorry, just my mistake. So I'm going to select a block and run it. There is a command which is going to give you a vector of all a vector of names of all the files which are currently available in your working directory. So if I previously ran the get working directory command, this was this command. This was a folder. Yeah, check it by the path, but I know that it is my current directory. And yeah, you can see it's just a lessons in PDF. This stands for this. There is a file from SPSS. It's also visible by RStudio now, and so this is there is the 7 files, and there is in fact 7. Yeah, this one is like a temporary file, so it's not counted because it could be seen, but by RStudio because it is currently it's just something like a log file which is currently run by RStudio. So this is not counted to this, but yeah, there's 7. Yeah, there are 7 files now. So by this command, you can realize, for example, we are willing to, for example, if I would like to import this file into my current R session, I can check by this command. Okay, R is able to see it, and that's pretty good starting point to start import the importing process of this file into currently running R session. It could happen, for example, from some reason or other, that your current working directory is set to different folder somewhere in your computer, or be some connected cloud or whatever, and you would like to change, for example, your working directory to kind of different or to different subfolder. So how to do it? It can be done in several ways. The basic command is setvd, because this one is also something called getter, and this one is sometimes called setter. Get working directory and set working directory. Yeah. So set working directory means that you are going to use path, complete path, and copy it, for example, to this here as an argument around this comment. So from sorry, I would like to get as my working directory, for example, one folder up. Yeah, so this one, this is like my current working directory, but for example, I would like to have this one as a working directory, D1 folder, which is 1 level up. So I'm going to copy this path, and the problem is that R, the first thing is that R expects paths as a string, as a character. So we have to bound it by double quotes or single quotes. And the next thing is that R expects not backslashes, not 4 slashes. So this is just a bit bothering stuff, but we have to do it. No other way. At least on Windows it works like this. So this is the path. So I can try to replace it by the default one. And now I can try to run the command. Just run, okay. And now I can try to check it. Get working directory. And yeah, it is really shorter. So academic year to course. Yeah, I am here. And to make it even more sure, directory. Yeah, there are only 2 file source or subfolders, and it means that we are exactly here. We are exactly here because in this folder, because you can see it. R is able to see only this one, so we are pretty here. So it works. It works. Maybe even more comfortable is to use a pop-up window. So I'm just going to use this command. Sorry, the use this command that we're using, but as an argument, I'm just using a kind of special function which is going to open a pop-up window like this. I'm going to run it and see it. R session. My R session is pretty close. Like my R session is in English, but this pop-up window is in Czech. Because I think that this pop-up window is based more on current installation of my Windows, which is by default and our faculty by Czech. I know it from medical informatics practicals. Unfortunately, it's by default in Czech, but it doesn't matter. So I would like to have my organizer still here. for the next part of today's lesson. So just simply, I'm just going to simply copy it like this, Control C on Windows, and here Control V on Windows. So it was the path was copied here, and I can copy by pressing OK. It should be set now. So by checking directory, yeah, I'm here. So it's able to see this content of this folder. So now it's right. So you can see maybe that this is like the most comfortable way. Let the RStudio asking you by to manage your working directory by clicking, or even you can do it like, you can see, you can like try to click to your final working directory. If you want to, you can just try to click this and find a working directory. It also works like this. It's not yeah, there's no only way just to copy it here, but you can also choose it manually by clicking and clicking, browsing for your working directory. Well, so this is important. I'm just going to check if I'm right. Yeah, I'm right. So this is important. There is no when we are starting to import anything to our current learnings, our session. So the first kind of data we would like to get from somewhere to our art session is a plain text data, plain text. So we are going to use two work hours functions. Means that all of the stuff is based on these two functions. The first one of this is just a read lines. Means that by this function you can particularly read a bunch of text, bunch of plain text to our R session, and similarly by write lines, we can save whatever which could be written in plain text. It means that almost whatever which could be represented as a plain text from R session to the file to local drive, for example. So there's a prepare code. It's also here. So I'm just going to show you how to open a web page using R. There's a command browse URL. You know that the abbreviation URL stands for Uniform Resource Location. And the page which is right now is just a web page of this course, Introduction to Language, which is posted or published at our departments, our institute web pages. So you know that I'm going to check what is the source code of the page, of this web page. Usually, if you are on a let's say like kind of normal web pages, all these kind of pages are definitely done or written by HTML, because there's a very large proportion of static attributes. So there's nothing like some dynamic. It's like, for example, some searching for flight tickets, or I don't know, some Google searching, nothing like this. So this is absolutely hard typed on this web page. So if I'm going to take a look at the source code for this web page, this is what I get. I got too much lines of HTML, especially this cluster of lines. Yeah, the text is like hard typed on the web page. And this representation, this source code, which is written mostly in HTML, and part is written in some JavaScript, and part is written in some CSS like Cascade styles sheets. All of this could be downloaded to from some internet. Sometimes this kind of work, data analysis, it's called web scraping. You know URLs of some pages, and you are for some reason interested in content of the pages, you can simply read the pages to your R session, and for example, by some ongoing analysis, you can extract some, for example, fruitful piece of information. Yeah. It's legal. I think it's still legal, but sometimes there are some discussion on if it's ethically enough or not. Yeah, maybe. From my perspective, I think it's because okay, my attitude to this is that if you are able to see it, whatever the content of a page, like by your naked eye, like now I'm just seeing it at this page. For example, I'm able to see, for example, some Facebook profiles, some Instagram profiles. if I can see it by a naked eye, it means that I am able just to take a paper and pencil and rewrite whatever is written, or yeah, whatever is written on a Facebook profile page, or it means that the data which are stored there are not like hidden from public. So they are publicly available. So I can take, or I can just take a snapshot of it or whatever. So it means that it should be illegal. Yeah, this kind of the kind of data scraping or data downloading should be illegal. So there are some, as I told, there are some article discussions about it. Maybe why not? It's good to discuss about these kind of things, but it's both legal and ethical from my side. Definitely, it's legal because if it's like publicly available, the page is publicly available. If you are going to break some passwords to get to some yeah, hidden parts of my pages, until this, we are doing what we are doing is so legal. It's definitely legal. Even more if we are just trying to web scrape our web pages, like our department's web pages. It's definitely legal, but it's not so much interesting. There are not maybe so much fruitful piece of information. Well, from our institute purposes, so I opened this web page using R code, and there is like a code. Yeah, what would mean this code? I'm just going to use function readlines. I told you that this one is used to take some connection or take some name of, for example, yeah, just taking a name of a file. In this case, it's not like a name of a file, but it's a URL, just a web page link. But still, you know that if you have a web page, in fact, the web pages are in fact some server file. Yes, say server folders and server files. So in fact, it's still a folder or a file in folder, but it's not like there is no like a name, like for example, okay, my file dot txt. This is like a URL. This is just a name of the file. The file looks exactly like this, and this is like the file. Well, by this function, I can try to connect to this file, to web page, in fact, and using this encoding. This could be done. I'm just using Mozilla Firefox, but by right-clicking the server into canvas of the web page, I can edit the check. Sorry, but it means that I'm just going to show information about this web page. And what is important for me is that there is just a char set there. Char set means what is a basic char set of this web page. It's UTF-8. It means that I should specify it also in my code. Yeah, just to make sure that all the special symbols, for example, like in Czech language there are many special symbols. I pretty much hate them, but there's a big amount of special symbols, special characters in Czech language. So by specifying the correct encoding, I'm just trying to make sure that the text from this page, especially in this part, it's in English, yeah, but it could be also in Czech, is going to be downloaded correctly. So, and it's going to be saved, assigned to my HTML variable in R. So let's try to run it. Okay, there's a warning message. It means that the final line which is founded on this page is incomplete. It means that, like in Windows architecture, usually Windows expects from your file that if there's a text file, the last line should be like an empty, it should be a blank line. But you can see that this is the last line, it's still not empty because it's just a closing HTML tag for closing this HTML page. But there should be also one more line, like of number 244, which should be pretty empty. So by reading this page into my R session, I got this warning message. So warning means that it was done. It was successfully done. This bunch of code was successfully done. But there is a warning for me that the web page is not correctly coded. But this is like not my problem. If I'm just going to scrape it, it's a problem of a guy who just wrote this. Okay, honestly, it was also me, but this is an accident. That it was me. Well, so I forgot to write the last line, which should be empty. It should be like the next line after this, one line below. Well, so let's take a look at the subject by underscore HTML, and it looks like this. I just the first 20, but I would like to run it like all the stuff. Yeah, you can see that it was this is the last line 2, 4, 3. So it's okay. Just HTML tag, close the HTML tag here. It's okay. There's just a closing body tag. Yeah, also, and so on and so on. So all the stuff is here. Also, take a look at the way how the data are present here, because it's just a vector. I'm going to take a look at what this my HTML looks like. It's just a character vector. It has exactly 243 lines. Yeah, it's okay. It's valid for our source on this web page. Okay. And yeah, the first line is there, the second line is there. So it's okay. Yeah? So each line of this source code means one slot in my vector. So if I'm going to, for example, take a look at now line number 10, or just line number 10. So just G introduction to RScript language. So let's check it. No, yeah, that's it. That's it. Introduction to RScript. Yeah, the symbols like for \t and \t are for tabulators. Yeah, you mean it's just a space. It's just a gap, including exactly 4 spaces, like for tapping on your space. And it should be it's just the first tabulator, and this is the second tabulator. So yeah, it seems to be correct also. So when we are, if we are, for example, interested in some web scraping, this is the way how it could be easily done. This is like the workhorse function, how to download a web page from, for example, some web pages, which is similar to this page, be easily downloaded by this. Okay, so this was for an online source, and now I would like to get into our R console, our current running session, some text which is like saved on a local drive. And first we are going to make this kind of file, because by making it and exporting to local drive, I can employ the function write_lines. So this is the write_lines function. So let's take a look at the arguments. The first argument is text. This is absolutely the text we are willing to save as as a file to our local drive, for example. So this is like something like rhyme, just a paraphrase to Lord of the Rings. You can see it in it, but yeah, but the ring was replaced by R. Okay, not surprisingly. Okay, so the function paste is the way how we can just paste, concatenate parts of text into one longer line, and the separator. This separator means that it's just a new line separator. So at each index where is just a \n, it means that there should be a new line. And how to correctly display this in console. It's easy. It's enough just to bound it by a get function. Yeah? So I'm just going to indent this. So let's run it. You can see now it's correctly displayed. But this is only about the displaying, like the values of the text of all the letters, and it's pretty the same. But you can see that the \n, like a new line separated here, maybe also here. No, 3. So these are there in the area, and there are 4 lines. Well, so how to save this text? Yeah, this is like kind of so I like a kind of rhyme. So some kind of poet, let's say, some kind of poetry. So this is like specifying what I'm going to say. And the next arguments are still separated by commas, nothing new here. The specification of a file, which I'm going to save my text into, is by argument connection, which is abbreviated to con, equal to, and this is like a name of a file I would like to have it in. So my text, that text. And don't forget to include also the suffix here, because it's important for our. Usually, it's necessary to include suffix to make the things working smoothly. So we have the both important arguments: what to save and in which file to save it. And still, I'm just repeating, it is going to be saved in my working directory. So now I can see 7 files, but after the saving, I should be able to see 8 files. So let's take a look first like this. Okay, that is later here. And now I'm just going to take a look like directly the folder, my text. So let's open it. And yeah, the poetry is, well, the poet is really here. It was typeset here, so it's here. So yeah, this was the way how we just got the text of our interest into a file of our interest and into the folder of our interest, on our device. So this is the way how to write plain text from our session to a file which could be stored on a local drive. And an opposite example is that from some reason I would like to, for example, next day I would like to, for example, read this poetry back to my R session, new R session after 1 day. So I have to read it from the appropriate place where path where it's stored. So I'm going to use the second function. This was the write lines, and now I'm going to read lines. Since I would like to, for example, use the text, and I'm going to work with it, I have to save it to some variable. That's the reason. There's a difference between the read lines function and the write lines. While the write lines function is pure imperation, like yeah, I'm just going by this. I'm just saying to my R code, R session that okay, save this text to this file. Yeah. So there's no reason to assign this command to any variable, but in this situation, this is more than handy to assign the read text from local drive to some variable. So what I'm doing here, the connection is that I know that my file is called my_text.txt. Still applied that you should don't forget to include suffixes. And encoding is UTF-8. It could be, for example, spec by, if I'm just going to open Notepad++, I guess, or some other text editor. Yeah, I can see it's UTF-8, yeah. So sometimes this is not necessary, especially for English text. I think regardless of the encoding, I think that English basic alphabet like 26 uppercase, lowercase letters, I think that almost all encoding are able to read the English text written in English properly. Yeah. But just to make it sure, better to include encoding here. Okay, so read lines. So what to read and by which encoding. So let's run this then. Maybe yeah, just a quick check. There's a node existing now in my R session. So let's run it. It's done. My loaded text should be now populated by the poetry, and still it works like it worked for the web page. Each line of my poetry, or each line of my text is going to be one slot of my vector. And my loaded text is just a vector, including exactly 4 slots, 4 items, and lines stand for items of the new vector. So if I like to, for example, know what is the, the second line, just 1R to find them, which is definitely correct. Just to make sure, yeah, 1R to find them, yeah, it works. Okay, this is how to load a plain text into R. Sometimes it's really handy to be able just to import, for example, some plain text, because, for example, there is also some disciplines in data analysis which are more focused on some data analysis, like text analysis, rather than, for example, some number analysis. So, something also there. Okay, so this was for plain text. The next important data type is just a kind of tabular format, or just tables. So maybe the most, let's say, most simply, there is just simplest way how to store data in tabular format is just go using CSV. Means comma separated values. You know, definitely this kind of format. It means that you have a rectangular table. There is just a constant number of all values per each line, and the values are separated by a defined or by given separator. Usually, these separators could be commas or sometimes semicolons. Yeah, semicolons usually when they store some data of non-English speaking provenience. For example, in Czech, you know that we usually use commas as decimal separators. It means that if you have many, for example, many numbers in one row which use commas and and also you would have just commas as separators of your values. It means that there will be almost two times more commas per each line, and the handler which can import your data from a file to our session, we just separate all the values, not only with not all the values from them, but also just the parts of these values, because there's a part which is in front of the decimal separator, and part of the number which is like a decimal part of the number. So it will be absolutely rubbish. So it was really garbage kind of import, because yeah, the original meaning of the numbers will be absolutely it's not going to work. Yeah. So be careful on this. So for Czech, usually in Czech, here, for example, in Czech Republic, usually use since we use commas as decimal separators, we use CSV using semicolons rather than only commas because of this reason. Okay, so now we are going. Okay, so the most important functions, like resource functions, are read table and write table. It's similar to read lines and write lines. Okay, the read table is a table which is able to read a file just from local drive to your R session, and similar to this, write table is a function which is able to put or just grab an R object, which is let's say of some rectangular structure. It could be matrix or data frame, and you can save it, export it, and save it as a file to a local drive, to a cloud, or whatever. Well, the functions have some wrappers. Wrappers means that there are some special kinds of function which are similar to these two basics, but I think that in our course we don't have to use these wrappers. I think that read table and write table should be enough for us. So let's take a look at this code. It's also implemented here. And okay, so the first thing is that we are going to suppose that we have some object of our interest in our session. This object is in fact empty cars. You know, empty cars. Usually, empty cars is just our favorite data frame. Just to make a quick version of this, you can see the data frame. That's exactly 11 variables, 32 observations. I would like to save it as a file to our working directory. So our working directory is still even including 8 files at the moment. So we are going to use write table and the let's say important arguments we should know about, we should use specified, determine are the following. So the first argument is just x is equal, and it means what we are going to say. And we are going to say empty cars data frame. So no double quotes here, simply name of this object. Separator, this is important because separator is exactly the symbol which is going to be used as a separator of each two consecutive values within each line. So in this case, it's just a semicolon because it's absolutely safe to use semicolon. It's not used to. It's usually not used for any other, let's say, row in I don't know, in some number representation or some text. So we can be pretty sure that if we are going to take a look at empty cars and these numbers, there are no semicolons, and there's absolutely no reason to have semicolons within these numbers. There are only numbers, or like digits, and dots as decimal separators. Row names, for example, from some reason I'm not interested to have row names here. Why not? So I set it as follows. And the file is also important because it's just a name of the file which we are going to meld our empty cars into. Yeah? So let's try to run it. Okay, it was run, and in directory you can see it now. Empty cars CSV is already here. Also, don't forget to include a suffix here. Yeah. So this wouldn't be enough. Yeah, this is enough. So empty cars. Let's include it. Maybe it will be just yeah, very likely. We'll see. I think it would work. Yeah, it works. Okay, there are some Excel specialties you definitely know about, like very strange representation of some numbers as dates in this very older kind of format. Okay, I don't want to talk about this. This is like Microsoft Excel typical behavior, but yeah, the export definitely worked. Yeah, since okay, it worked, but there are some, let's say, not so unpleasant features about Excel, but this is not the stuff of R. Yeah, no, it's really strange. Okay, so maybe, yeah, okay, maybe, for example, what is also maybe interesting and good to know about, we are going to use one, okay, one of the references may be interesting because we are going to use C2. It's a kind of special comma separators format. Which is which usually works very smoothly, very well on Windows computers where the Windows was originally installed in Czech. So we for example, situation while you're throughout your studies at this medical faculty, because well, I think at all the school computers which are going to have in the library in our department, like medical informatics, maybe some other departments where are very physiology, but there are also some computers and computer practicals. I think at all the computers were by default installed in Czech, and CSV2 should work there very well because the Excel installations also should be, they also usually installed using Czech language as a default language. So this kind of wrapper should save our file within the fashion which is pretty appropriate to run it smoothly in Excel. So since it is a wrapper and it's a CSV, we don't have to separate. We don't have to indicate what the separator should be, because separator is done by the CSV. And CSV means that it will be definitely semicolon. If it will be just CSV, it will be comma. And CSV2 means that it's just a semicolon. Row names, it's also handled automatically by this wrapper. So for example, only two arguments are important: what to save and in which file to save this stuff. So let's run it. It's going to be rewritten, yeah, but it doesn't matter. Okay, it's done. I'm just going to open it using Excel. Yeah, and it works very. You can see that now there is absolutely no mess with the really strange where representation of some numerical values as the dates. Yeah, it was really strange. But now you can see all the numbers are numbers. It's pretty okay. It's pretty, yeah, it pretty works well. Numbers are numbers, and row names are just characters. So I think this is top, absolutely top and desired situation you'd like to have within this data set exportation. So yeah, so my hint for you, if you have used sample school computers, this is absolutely the best way. For example, to combine some, some R, maybe in the physiology there will be some exercise in R, maybe, I don't know. We'll see. But yeah, this should work. Okay, and next task, which is opposite kind of task, if you like to read your file back to your R session. So I'm going to rewrite it like this. So let's close this. I'm going to use this separator, yeah, and I'm going to now to read it back to my R session. So my empty cars is an object which is not populated now, but by a read table. I have to tell R what to read into the currently running session now. What is the separator of this file? The semicolon. Yeah, both the values are in double quotes. And if there is a header, definitely there is a header. Header means there were call names within the saved data. So yeah, so let's try to run it. But yeah, I'm sorry. So my empty cars. It seems to be promising. Yeah, that's it. So you can see that R tried to do some automatic coercion, so it automatically and independently decided what is an appropriate data type for each variable. Yeah. And yeah, why not? Because for example, these values are like integer, there are no decimal parts of this number, so why not? Okay, so this was about CSV. Next example, here is also a very popular data set of R. It means that if we have, maybe we have already we already took a look at this, I think, during this previous lesson. Now it's just about areas and the kind of plant, some parameters of this plants, and some species setters are versicolor and virginica. It's used to do some classification task. But for now, we like to write this data set to some text file, and it's pretty easy. Write table, and what to write. So access areas. Maybe I told you that sometimes this specification of the argument, like the labeling of the argument, is not necessary like this. So this works, and okay. So this works. Okay. Now here, and the previous is going to undo this. Now, yeah, now the arguments are labeled. So now this also works. Yeah. So both are possible. If we are going not to include the labeling of the arguments, it could work, but in such a case, it's important to respect the order of the argument. So the first argument should be the R object which we are going to, let's say, save as a file, and the second argument should be the name of the file we are just creating using R session. The appropriate order of arguments could be get from help. Yeah, we just call for help, and you can see it first, which is X. X is the object to be written, and the second argument is just a file name, yeah, character string naming of here the desired file, just the created file. Okay, that's it. So as I told you, it's not important, it's not necessary just to include the labeling of arguments, its name, their names, but in such a case, it's more than important to respect the order of the arguments, which can be the knowledge about which could be get from or using the help of files. So the result is help. Now I'm just going to read it one more time. So readable. The file is called iris.txt. Separator is simply a space. And also, you can see it. I didn't specify a separator in my write table function. If you are not going to do it, similar to me, then it's the default value for this argument. You can see that separator is by default equal to one space here. So one gap. So it was just a default behavior. So I have to tell it to R now that there was just one gap as a separator. Header 2, definitely it was header. It's automatically saved because you can see that columns 2. Columns 2 means that there will be header. So two string as vectors mean that all the strings or all the variables which are going to be recognized by R as characters, the strings in other words. It could be recoded as factors. It means that R is beside the fact that it's going to import it, going to also it also could just label the categories, so extra categories, and make a factor from a vector. Usually, it's not necessary. There's not much. It's not so much useful. So it's good to say that we are not expecting this behavior. So by setting this argument to be false, this is the appropriate method. Check names false means that all the variable names or variable labels which are included as in a header as a call names are not going to be checked for some validity or some correctness. It means that in R, the names of variables, names of object in general, should follow some basic rules. And the rules are particularly there should be no gaps in name of your variables. For example, name like. For example, if there will be just an object like hello world, it's not good. I'm sorry, world. It's not going to. It's not going to work because it's aspect symbol, and the aspect symbol is the gap here. It's the first rule. The second rule is that object shouldn't start by a number like this, for example. Also, unexpected symbol in one hello. This is also from. Well, this could work. Yeah. The problem is now that the hello one is not found because it wasn't like name or there wasn't a value assigned to it. But now hello one works. But if I would try to do this, there's a problem because of the starting number one. So these two rules: no gaps in variable names and no starting numbers. These two could make some problems like this. And by check names, this handler readtable is going to check. If we just set to true, the readtable handler is definitely going to check all the variable names. And if there will be problem like some starting number or some gap in the name of variable, is going to be replaced. Or the starting number is going to be replaced by other. There are going to be, I think, importance of like X, and then, for example, will be just the original name, variable name like this. So this is valid. Not found, but it could be. Okay, it could be. Yeah. And the names are going to be replaced by dots. So if you know that your variables are labeled correctly and they follow these rules, it's not necessary just to tell our session to check the validity of your variable names. Call class is also usually argument means that we are just trying to let's say automatically coerces all variables into one data type, and in this case it's just a character. It means that we would like to have all the values or all the variables as character, and it could be handy. We know that in original Aries data set, the first four are numerical, and the last one is factor of 3 levels, but the levels are just strings, like checkers. So by this reading, I can just have even the first 4 variables as numerical one. So let's try to do it. Okay, and my arrays now looks like this. So it was imported correct successfully. And structure, yeah, all the variables are checked as I wanted. You can see that the variables were they just follow valid, let's say, smart code, how they should be labeled even before. So this checking wasn't necessary. And for example, the species, you can see it in the original. Here is the species is a factor, yeah. This is what we have it before, yeah, it's just factor. But by this string as vector false, now you can see that in my arrays, it was when it was imported to my arrays variable, to my arrays object, the species are treated also as on their character. Why not? From my perspective, it's maybe even better, because yeah, at this moment we are going to do analysis. It was only about to just to check if I'm able to import it, read it into R. So this is the behavior, correct behavior. Okay, so well, so my arrays is like, I'm going to take a look at the first 6 lines. Yeah, right. Yeah, it is very promising. Well, so it was about CSV, comma separate values. Now, very important part is to be able to import or export data. What is this? Sorry. Okay. Well, it's important to export files which are original, let's say, as Microsoft Excel files, because it's very usual format, still very usual format. Many computers and in many laboratories to store data in a Microsoft Excel. So how to do it? So there are several points before we are going to start to import data from Microsoft Excel files. Okay, because we need a special package to do this stuff. The package is called OpenXLSX. This is not the only one. There are many packages you can do it, but OpenXLSX is one of the best. It works very smoothly. It's easier to be used. So yeah, I like this one, and my manager are going to use it, because yeah, there are really no problems with using it. Okay, so this is the first thing. To install this package, I'm going to show you how to do it. And the second thing before we are going to start is install a tool which is called RTools, and this is like a kind of tool which are able to handle the archive, let's say, kind of format, because Microsoft Excel is in fact an archived version of format. I'm going to use Microsoft Excel here, for example. Just some quick example. Yeah, because it means that if you have an archive format of one, okay, so like A, B, 1 and 2. Let me just say it. Okay, so I'm going to yeah, I'm going to rewrite this suffix to zip. Okay, so you know that if there's an archive version of format, it could be unzipped. Yeah. It could be just yeah. You just try to search for the original or audio files which are like in this kind of archive kind of format of file. So I'm going to rewrite this. It seems like a heresy, very heretic, but yeah, I'm just prompt to do it. And you can see that the icon of a Microsoft Excel has changed to be an icon of a zip file. So let's take a look at this. Now you can see what is the proper content of your Microsoft Excel file. These are some Excels which are just the, I think, yeah, Rails, the properties, Excel, content types. One of these is worksheets. Because worksheets. This is important. Excel worksheets, XML sheet 1. So let's take a look at this. I think I'm able to open it in some maybe text editor. So I hope it. Okay, it's going to be Explorer. That's very interesting. Well, but the thing is, yeah, you can see this is. Oh my God. Yeah, this is as I written to my table. It was just 0, 1, and AB, I guess. So I don't know. Should be somewhere here. A1, A2, A1, B1. Okay, I think the values are somewhere here, or maybe in a different Excel. But the thing is, the important thing is that anyway, Microsoft Excel files with the suffix XLSX are archived formats. It means that it's not so easy for software like R or any other software just too easy to handle with Microsoft Excel files. And the only one software which is able to do it, let's say, smoothly is Excel itself. Yeah, it's not a surprise. But other software is not able to do it, like some also like browsers or R or whatever. So you have to install a tool software which is able to which is able or which enables this functionality to work with archived files. It means that it's going to. It means that the software, yeah, there's a software to do it, and the software is called R-Tools. There is a version for Windows, and there is a version for Macs. I suppose that there's no one who is just working on Linux. But if so, the Windows version, I think it could run on Linux, or there is definitely an original Linux version. You can take a look at this if it will be needed. Well, Windows and Macs, yeah. So these two, I think these two will be enough. These two will be definitely. So for Windows, for Mac. So these are instructions for Windows. You can just, I think they have the current version based on your like if it's the 64-bit version or 32-bit version of your Windows, and for Mac, I think that there is just a download from this GitHub, or maybe this one is current. Yeah, it should be pretty easy to be done. So just download it and follow the instructions which are going to be enabled for you. So yeah. Okay. So this was the first thing. And in my computer, I just already do this. So OpenInstall is already installing. How to install this package? So if I'm just going to open this right-hand side Windows frames, there is a package tab. If I'm going to click on it, there's the install command. So let's click on it, and there's going to be prompt to insert a name of packages I would like to install. So repository crun, this is the default choice, and don't change it anyhow, because yeah, this is like the largest repository for R packages, so this is absolutely the best choice. Package name, OpenX/6 in our case, so OpenX/6, just write it down. install library. This is like a default path. I think that there's no need to change it. And install dependencies, yeah, definitely make a ticket here. Check for this option because sometimes we have the packages are dependent on some other packages, and the package itself, without these dependencies, the dependent packages couldn't work. So it's more than important to install both the package you are interested in, or there's one function or one or more function of the given package, but the package couldn't be run itself without a dependency. So for each time, make sure that we are also willing to install dependencies. So this is our choice, and by clicking on install, the install procedure is going to be started. And don't worry about it. I think the installing procedure is going to take maybe 1/2 of a minute or 1 minute at the most. Yeah, so maximum. So don't worry about it. Definitely we work with that. It's not like a 1 hour procedure. Yeah, don't worry. 1 minute maybe at maximum. Okay, so then also important one is install. Okay, installation of package is something we are going to do, for example, once per year, because there are some new updates of packages. So some time to time it's necessary to make update to get the new functions and to let's say have your R session or your R packages in somewhat, let's say, current versions, yeah, which are compatible with new versions of new packages and so on and so on. So installation of packages, for example, one per year is absolutely, maybe one per 2 years is also enough, but one per year is absolutely, absolutely enough. It's absolutely okay. Then at the beginning of each session, when you know that we are going to use OpenExcel as a package as a tool for importing Excel files into your R, you are supposed to run this kind of command library and name of the package as an argument for this function. This means that Arthur is going to be aware that he or she is going to use this package, and he's just going to prepare, let's say, all the functionalities for you, because it's just it's just like something like a additional functionality, so it has to be initialized in the beginning of the session. So by this, I'm going to initialize. There's nothing more, only run once at the beginning of the session. So now, for example, I'm able to use all the functions of OpenXLS6 package from this moment. And last important thing, still going to the fact that Microsoft Excel files are archived. You have to run this special call. It means that you are specifying what is the path to your RTools installation. In other words, we are telling by this to your R session where is your RTools software installed. Yeah, this is the software I showed you before, like this. Yeah. If you are in Windows, the first link, the second link if you are in Mac. Well, so yeah, so RTools, so 3 things to repeat. RTools, install it. It's the same like package. Install it once. Install it, for example, today or when you want, and you are safe, for example, for the next year. Definitely after 1 year, usually we just update, so you are going to be prompted by your RStudio to install a new version. Yeah, it could happen, and it will definitely very likely happen. But yeah, it's enough to install it once per year. Then, so that was the first thing, RTools. The second thing, you have to specify this at the beginning of each session when you are going to use OpenXLS and use functionalities. 2 things are needed to be done. This line to initialize your library OpenXLS6, just to install, so it's already installed, and this line to inform our session where your installation of RTools is by providing a path to the installation. Well, so this was for the necessary stuff. So in my case, I'm just going to run this. A good piece of news is that if I'm using Windows, I think that this is like the default path, so you are not supposed to change anything. Yeah, I run it on many Windows computers, and path to R2s was exactly the same. So once we are just going to install this, I suppose that vast majority of all the Windows now are those 64-bit versions. So run this, save it to your computer, follow the instructions, next, okay, it will be installed. Then I think very likely, almost 100%, this is the path to your R2 installation. So this and this will make you possible to handle with Microsoft files in R. Well, and now finally, interesting stuff. So how to save an R object from R session, R console, to a file with the suffix x86 as a Microsoft Excel file, to a local drive, for example. So first thing is, do we have to create an empty workbook and assign it to some variable. So I'm just going to create an empty workbook and assign to my workbook variable. So like this. Now, let's take a look how my work looks like. Yeah, this is just a workbook object, okay, but no worksheets, no sheets in this workbook. Yeah, definitely. That I think that's clear. So it's just an empty workbook at this moment. I'm going to use empty cars, empty cars, and I'm going to assign it to my table variable. Yeah, just to make it. Yeah, I can use directly my empty car, but I can just suppose that my table is just, let's say, a result of my work in R. And now I would like to save my table just as an Excel file to my local drive. So now I have to create a sheet in my workbook, and it will be just a blank sheet, yeah, but it will be the first sheet in my workbook. So my workbook is called workbook. So arguments to add worksheet function there are two arguments. The first one is just what is the name of my workbook. My name of my workbook is just my workbook, and the next is just the sheet name. The sheet name is my first sheet. It could be an effect or it could be almost anything, but don't forget the thing that I think that, yeah, I guess that Microsoft Excel is limited, the names of sheets at Microsoft are limited. I think that it cannot be longer than 32 characters, something like this. It could make some problems. So it's rather, I would rather use, let's say, shorter names of sheets. So this one could be okay, but for example, some long name of of sheet could make some problems within the saving. So my first sheet. The next, we would like to populate my sheet by the data. So we are going to assign my data, which are stored now in my table variable, my table object, exactly to my sheet, which is called my first sheet, and it's a part of my workbook, Excel workbook. Yeah. So the function is write data. First argument is what workbook we are using now. It's just my workbook. The second argument is what is the sheet we are using now, where the data should be stored and populated to. And row names, call names. From I'm not interested in my row names, call names. Yeah, these are interesting for me. So row names, calls, and call names too. Also make a note that there is a bit different notation, because there is, for example, no row names within a separating dot. Yeah, because this is like a kind of extra additional package, and these functions are part of this package. It was developed by different people, yeah? And that's the reason why there are some, let's say, inconsistencies between these arguments. So this is the R world we live in. This needed to be respected, yeah. So in this package, the functionality for row name and call name is labeled by this, not like by this or by this. Like it is, for example, for data frames in base R package. So unfortunately, yeah, the things work like this. And X is the object, and this is my table. Yeah, so this is also, I think, pretty clear. Okay, so I have to run this firstly. So if I just take a look by extending to my workbook, you can see that there is already one sheet, which is called my first sheet. This absolutely would like to have. Follow this command. And now we are getting data. Okay, so let's take a look at my workbook now. It's an object of list. I can still see it like this. Okay. Okay, the next step is optional. So I'm going to only talk about it like you can, for example, automatically set the weights of your cells in Excel and things like this. You can, for example, set a bold font style or horizontal align your values in your cells, or going to the right or left, or justify it. It's up to you. It's something which affects only aesthetic part or aesthetic, let's say, effect of your Excel. So not so important. It's absolutely optional. So we are not going to go into it, but so this is optional. But once we just populate our sheet, my first sheet, by our table, by our data, the last thing important is just saving all the workbook to a file. So function is save workbook. What to save? My workbook, all the workbook. What is the name of file we would like to save it to? It's just my table.xlsx. Also my note, don't forget to include the suffix. And override equal to true means that, for example, write this command or you run, for example, your script during your R session more times, for example, more than once. This means that your Excel, my table that Excel is going to be overwritten all times since one this is run, and it's handy because, for example, without this argument, there'll be something like a versioning of Excel files, like Excel is going to do the bare stuff that going to do many versions, copies of the of this file, and it's just appending round tables with a number of version like 1, 2, 3, and so numbers like these integers in round tables at the end of the name of this file. So yeah, I think it's not necessary. But if you would like to have all the versions, you can set it to false. But I think that from my perspective, it's important to have one final workbook, Excel workbook, which is D1 I would like to have. So I'm like afraid of this overthink. Let's save it. Should we say our working directory? My table size it's here, so let's check it. My table size is still here. Okay, so what? I need to check it one more time. Okay, it just disappeared. It should be there. Find the right 20 cards. My table. Okay, you know what? I'm just going to run the code one more time. I'm not sure what is the problem. So package environment. Now let's do this stuff, and finally this stuff. Okay, okay, should be. This is really interesting. I'm not sure why it doesn't work now. Directory. There, my table. You can see it has some size like 8 kilobytes. it should be like a really existing file. One tables one more time. Yeah, the error message just saying something like it was just moved to other folder. I'm not understanding this properly, to be honest. Library book looks like I think it should be okay. This. Seems something like I table 2. My first sheet. Okay, everything's going to work so far. My first sheet, my table is just empty cars. Okay. So interesting. My data. Let's say remove using a different name. Okay, it's really strange. I don't know why it doesn't work. It worked, yeah. It really, you know the word, the sentence. It worked yesterday, but it's really strange. No, what's different? Bullet Pro, I don't know. Something has changed. Okay, so it's really strange. Well, you know what? Okay, so I believe it doesn't work. Oh my god! You know what? Somewhere. Excel file. Now I'm able to run some Excels. My data. Okay. Okay, there's this Excel. I'm able to open Excel files. Okay, that's the first thing. Book. I just start here. So empty cars. This should work. This should work. Saver book. My work book. This one title. I don't know why it's not working. Okay, guys. I'm going to go back to this maybe at the beginning of the next session. I don't know why it's not working now. Really, really strange. I really don't know. Okay. It's still claiming something like it was moved to another folder. I don't know what does it mean. Well, so okay, I'm just going to use okay, maybe going to install it, or maybe this is also a good idea. Let's say nothing. I'm going to run it one more time. All the stuff because we are still could be still down. Directory. There. Well, so library, doing this, this. Well, in directory. No, it's not would be like that. Time. Let's hide using. Okay, open it. It's okay. This should be the correct working directory. Okay, one more time. Library works. I'm just choosing the appropriate path to zipping, unzipping. I just install your articles regarding the unzipping. So the archived formats. Creating a new empty workbook. I'm just assigning my empty cards to my table object. I'm creating a new sheet, which is still empty now. I am writing my table into the sheet. And finally, I'm creating the workbook. Okay, this is the workbook. Yeah. This is the Excel sheet. I really don't know if it's going to work. Okay, it's not going to work. I don't know why. Okay, it really works all the time. Absolutely works all the time. But not now. I know why. Okay, really strange. Really strange. The last thing I can be able to do is to show it for that it really works is that I can run the check version, which really I know that it works. And to run exactly the same code. And okay, splitting directory. Okay, it's in check version. This. And let's try to run the check version of Excel. Pretty good. This definitely worked 2 days ago because there was just a Czech version of this course, and this session version. So I still believe this should work. So data, okay. Now saving the workbook. It has to work. Okay, as you can see, it works in Czech version. I know why it works in Czech version. So the empty cars, and it works now. You can see that it was created just a second ago, like today, 20:31. Yeah, in this minute. So it works in Czech. I don't know why it doesn't work in English mutation. Sorry for this, but you can see that it works. I will try to inspect it during the weekend. So let's take a story. Okay, this is so sorry for this delay. Yeah. I try to expect the export to Excel and try to realize where is the problem, and we can run it with 1 minute at the beginning of next session. Yeah, I don't know why it's not working now in English. There must be, I don't know. I think I'm not able to realize now what could be the problem. Okay, so okay, by considering, I'm just going to land this file from the Czech version because it was just created now, and the content is still empty cars, so it's pretty understandable in English. So it should be called my table. So this is was running my table, and just in order to make a file which is able to be. It seems that there is a problem with this kind of name. My table seems to work. Okay. It's really interesting not to be. I wasn't allowed to make an underscore between the text. Okay. Very strange things. So maybe it is going to some really strange reason. It seems that the underscore was the problem. So I'm going to write one more time, make it a last attempt in English iteration, but saving it using the name without the underscore, like only my table, like this. Where's my directory? So I'm going to save it using the name without the underscore. Yeah, it's updated now. It works. Okay, I'm going to delete it. And let's do it one more time. Okay. Okay, yes, you can see it works now. The only difference is that there's no underscore between Y and T. I really don't know. There are some things just in the middle between the earth and the heaven. I don't know, but now it works. Okay. Well, so I have this. I've got this file saved in Excel finally, and now I'd like to try to realize it. Okay, for example, it's the next day, and I would like to, for example, read this file back to my session because I just started for example, a new session, but I would like to work, for example, on this table from some reason, for example, with some analysis, whatever. So there's opposite task. I've already got the table which is saved, yeah, but I have to read it from a local drive back to our session, new current learning our session. So the function is read xlsx. The first argument is xlsx file, which is just the name of my file. Supposing that I'm in my working directory, so by typing now a directory, I can just check if R is able to see this file, and it is absolutely able to see it. So it should be uh, correct, smoothly read into our session. Sheet number one, yeah, you know, because there is only one sheet, so it's just the index of the sheet, and but you can also use the name. Yeah, there could be also my first sheet. Yeah. Both should work. Index of the sheet or just a just my first sheet there. My first sheet. This should also work. And call names too, because I know there are call names. These are the call names in Excel. Okay, so let's try to run it. My data now at this moment doesn't exist. Let's try to run it. Okay, it seems to work. And the data are here. Perfect. So this was okay. Okay, so from some reason, I really don't know why, the hyphenation here, sorry, the underscore here was the absolutely the origin of all the problems, of all the 15 minutes of my during we are able just to save the data into workbook. So I don't know why. Directory, it was changed. So this is not what I'd like to have. Directory. Okay, it's okay. Well, so this is for Excel. Okay, so maybe you can try it like this. To use rather sheet name, so I'm going to remove this. Remove my data now doesn't exist, and by reading this, rather using the name of the sheet with index still works. So both work. Well, now this is something which could be interesting for people. For if you are someone of you, for example, already working in some team or some laboratory, for example, or with some team which is somewhat skilled in statistics or in reading some statistical outputs or some outputs of some data analysis. Now what we are going to do is way how to get a quick outputs without any external packages, without any painful setting of or creating workbooks or populating workbooks or whatever, which was, for example, you can saw this for Microsoft Excel. It was a kind of not so much trivial, but if, for example, your supervisor or whatever are going to study a PhD study, whatever, we are going to be in some close, let's say, co-working, cooperation with your supervisor. And for example, he or she is definitely skilled in some reading of some statistical or data analysis outputs. In such a case, it's very handy to be able just to make a print of your console, just a console output, just like a snapshot of your console, because definitely guys like supervisors are able to read basic statistical outputs usually, and so he or she is able to look at the appropriate lines, and this is like the way how you can, for example, get the output very quickly without any packages, without any installation of hard tools, without any specifying or defining what is the, I don't know, path to your hard tools and things like this. This was necessary for Excel, and Excel is an output which is definitely invented by many people. Why not? But this is a different kind of task. For example, this is like a situation that we have two vectors. We are going to have two vectors. First one is called males. The second one is called females. And and males. Both vectors include exactly 100 numbers, and these are just artificial data, generated data by random. But supposing that you can see that males is just the vector of 100 numbers, which follows standard normal normal distribution, and this normal distribution has a mean value of 175, let's say, centimeters, and standard deviation of 10 centimeters. This is pretty close to the real situation. What is the let's say average body height of males, and what is its variance or variability measured by standard deviation? And similar to this, so we got, by the first command, we got 100 of numbers, which stands for 100 of recordings of independent body heights of males. And similarly, the vector females will be consisting of 100 of values generated by a normal distribution with a mean value 160, let's say, centimeters, and 10 centimeters of standard deviation. So by this, we got two vectors, males, like this. I'm going to take a look at this structure males, structure females, 100 values, yeah, and we can also take some, for example, look at some plot, like, for example, I'm thinking that this should work. If I'm going to use a box using a list by concatenating both males and females. This should work. Yeah, you can see like there's something like a plot. Yeah, the first one stands for males, the one for females. So there's you can see that the average value for males is a bit higher than for females. Okay, so these are numbers. And for example, we can compare these two vectors by a statistical method, which is called g-test, by supposing that both the distribution, sample distribution of these two vectors follow a normal distribution, but we know it because we generate it using normal generator of normal values. So t-test is an appropriate test how to compare these two subpopulations. Okay, one more time. Okay, now it works. Well, now it works appropriate. So one more time, it should work. Yeah, it works well. So what was done? Well, to example of t-test, we can see there is just some t statistics. If this is just higher than 2, usually it's statistically significant. P-value is like a probability of getting data which is more the same way or even more in contrary to the claim or to the hypothesis that there is no difference between the mean values of these two subpopulations, but definitely there should be difference. Yeah. So the probability that we will make an error by rejecting the null hypothesis, if it is held, if it is true, it's so low. This is in fact a 0. Yeah, it's 10 power to minus 16. It's a true 0. So we are not going to make the probability of making this kind of error is absolutely 0. So we can feel free to reject the null hypothesis. It means that the null hypothesis claiming that there is no difference is not true. So there is no. So there is difference. Yeah, there is difference between the between these two statistically these two values. So this is a t-test, but you can see that the output by the t-test is not so much good structured. Yeah, it's not structured because it's like a plain text. Yeah, plain text. The lines are different lengths and so on. So how to capture this? The first, because this is a kind of output which, for example, your supervisor is definitely going to be familiar with. So I can run it by this. There is a function capture output, which means that I'm going to capture the t-test. Okay, the first argument is what I'm going to capture as to a file from the console. I'm just going to capture this t-test mail emails. I'm going to save it to file t-test.txt. So let's run it. Let's run. It's of course saved to my working directory. Is here. T-test. Let's take a look at this, and this is exactly this output. Yeah. So you can see that it works. It works very well. And for example, this is a kind of, for example, file you can send by a quick email to your supervisor when you are doing something like this. So not worrying about some Excel. As you can see, I also got in some troubles to make the output using Excel. It took maybe 15 minutes to realize that there was a very, I don't know, it was a bug or feature not to include hyphens, sorry, underscores in your names or output files. I don't know why it usually it's possible, but not now. Strange. But this was pretty easy. It was pretty quickly done, and your supervisor is definitely skilled enough to be able to look at the appropriate line. And this is the most important line from this test. Yeah? You can see it was mails and also compared. These are the statistics, e-value, and t-statistics. Now, and some claiming how was the alternative visit formulated, so it's not so much important, but this works. Also, it could be done using by sync command, double command. It works like, okay, this is like the first command sync. The argument within this function is number of file, name of file. We are going to populate by whatever is written between the consecutive two sync commands. So there will be just a t-test. Then you can, for example, write something like, I don't know, hello, my supervisor, for example. There should be also a new line. It's maybe we already remembered it. It will be done by \n as a new line. And for example, something like this, and also some like this. For example, there should be some new line here, maybe. So this should work. Okay. Sorry. I think that let's change the working directory. Yeah. Okay. So interesting. Yeah, maybe I'll tell you I don't like RStudio. I like RStudio like this environment. This is not what I would just prefer to my daily work with R. I'm just using command line or RGUI with the Notepad++. So because you can see there are some strange behavior like this. Oh my God, what is it? Yeah. But for illustrative and teaching purposes, RStudio is usually preferred because it's like many things you can click, like the installation packages and so on. So let's try to run this. Yeah, I hope this should work. Okay, this is a little details. So this is the new file. it works. Oh, my supervisor, this is the output of t-test, some new lines I indicated here, and yeah, thanks, bye. Yeah, and this is, I think, when you can share it with your email or some, I don't know, instant messenger, whatever. Yeah, this is like, it works very well. And if we are just commuting and sharing these files, for example, on a very quickly basis, for example, we are, I don't know, work with some, yeah, some team, for example, we would like to share, for example, even between, for example, two laboratories, two rooms, which are very, very close to there, but, you know, this could be used because, yeah, if you are skilled, if all the sites are skilled enough to be able to read in these outputs, I think this is the way how to share your outputs. Okay, next thing is maybe like, this is maybe a bit advanced stuff, but still I would like to have introduce it a bit because it's exactly the stuff which can be done only using R, for example, not by Microsoft Excel. We need what is this about? Okay, maybe you know that if for example try to for example cooperate with some journal or manuscript making, you know that usual manuscript templates are either in Microsoft Word or in some special typesetting software or tool which is called LaTeX. Yeah, it's called like sorry, I don't know this. Sorry, but because it's usually on tech. Tech or LaTeX. This is just a professional typesetting software which is able to, for example, typeset mathematical notation correctly and whatever, for example, some chemical structures correctly, and so much more better than Microsoft Word can. So the power of R is that if you are doing some, for example, modeling, I'm just going to use some linear modeling. So this is something we are going to go more deeper into the next week. But for now, it will just to get some linear model, and the output of linear model is usually some summary table, and this summary table is expected to be formatted in a special way. For example, for the manuscripts. Yeah, they are just expecting to get a special way how to format it. It could be definitely in Microsoft Word, but it's very painful. So, you know, you get some table from Microsoft Excel, you are going to copy it to Microsoft Word. You have to do some borders and things like this, and manage all the cells, some horizontal aligning and things like this. I think this is not so much interesting stuff. It's like a boring stuff, but it's to me, for example, it could take 10 to 15 minutes. Yeah, not so much low. So yeah. So how to overcome this in a very elegant way? So the first thing we have to do is have an Xtable package. Yeah, Xtable package. You can still go to this right hand side menu, go to packages, install, and try to find Xtable. In my case, it's already installed there, so but it will get there by this and by clicking on install. Then you have to initialize it like this. And now we are just for this illustrative purpose, I'm just going to do this linear model. Linear model function L for linear model means that I'm going to take a look at empty cars, still the same empty cars, and I would like to ask bilinear modeling, bilinear regression, if there is an association between miles per gallon as a variable, as a dependent response variable, and horsepower and number of cylinders of a given car brand. Okay, by running this model, I go to model. Let's take a look at the model. Okay, I got some linear coefficients. It means that what does it mean? If we have a car brand, like in general, so appropriate, so in like on average, per each unit change. Okay, if just horsepower is going to be increased by 1 unit, the miles per gallon is going to be lowered by 0.01002 miles. It means that usually I think that the fact is that the heavier the car is, then the more horsepower it's required. Yeah, so this variable is going to is increasing, but the heavier the car is, the low just a lower amount of miles per gallon is able to 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 ride. Yeah, so this is the deal. Similar to cylinders, if the number of cylinders is going to be high enough, it's usually going to do a very heavy car. It means that heavy cars are not able to drive for too many miles per 1 gallon. So it means that the signs are, I think, in the correct direction. Yeah. By increasing horsepower and number of cylinders, usually both the variables are correctly with the weight of the car. Yeah, going to just the distance which is able to car the car is able to do is going to be lower and lower. So miles per gallon is going to be lower and lower. So I think it works like somehow. So we go to linear model, and if we are going to linear model, we are usually interested in summary of this kind of model. That's a typo. Okay, this is the table which should be output to a manuscript. Yeah. So estimates, these are estimates we have seen before. Standard deviation, t-values, and p-values. Also, if the p-value is lower than 0.05, you can consider such a variable as a significant one for the linear model. Okay, but this is maybe interesting, but you should have go by this, for example, to Microsoft Word, make some, because this is like not like a table, it's just a plain text. It's just plain text from a console. So if we are going to save it, yeah, my word is now in check, but don't worry about it. It is not like a table. You can see it's just a plain text. Yeah, I'm just going text like this. So in case that you would like to have it in table, you have to copy it in cell by cell or value by value to cells. So it would take much time to handle it, to treat it. So how to do it more elegant? Okay. If you run this command, supposing that, okay, you got something like this. I told you this is like a LaTeX code. You are not supposed to know anything about LaTeX code to use it. This is appropriately coded. So the only thing you are supposed to do is just copy this and enter it to appropriate editor of LaTeX. So for example, text on web. It's one of the few LaTeX online editors, and this one is a Czech project from Brno city, from University of Mendel, Johann Gregor Mendel. You know the name of Johann Gregor Mendel from genetics, definitely, like Punnett squares and one gene hereditary. You know the stuff, definitely. So this is like a LaTeX editor. Don't worry about the code. The code is like, this is a next programming language, but for typesetting. Yeah. So I just do this. I did this. I copy this out from my console to editor, and I'm just clicking on this PDF icon, button, and what I'm doing now is perfectly coded table, which could be put this way as it is now, as is to your manuscript. I would also bet my shoes that you can use this table to your camera ready version. So this is just the last version of manuscript before publishing it to worldwide, yeah, to French journal, or to share it online to all internet. As you can see, it's absolutely perfectly formatted table. I think you are able to do it much more. Okay, at least you are not able to do it, sorry, quickly in Microsoft Word. In some finite time, some limited time. Okay, you can do it, yeah. You can get closer to it, but this was like on several clicking. It was just one clicking to run this, the next clicking for copying this out, the next clicking was just, if I don't take on web, for example, was just copying it here and click on PDF. I go to PDF and the table looks like totally professional table. You can see such tables. I told you in some professional journals, professional papers. So it's paper ready, camera ready paper, or camera ready paper. Okay, so this is the power of R, yeah, to do this stuff as quickly as possible. Okay, so, but as I don't, this is maybe kind of special. I believe that, for example, one or two of you, maybe more of you, that because we are, this is a special kind of, let's say, enthusiasts who are interested in art. So I think that you may tend to do some science in your life. I think so, but this is the way how to do it. There are more complex commands how to do it, but I think this is not necessary for now. Because, for example, this one is too much complex. It requires some knowledge of tech. So, but this one was absolutely okay without any knowledge. You could see what I did, and it was pretty enough to get a perfectly formatted PDF. Yeah, this is like the yeah, it's like a link to Techon Web. Yeah, like if you are interested, I mean, this Techon Web. Techon Web is enough to Google it. Well, and the last thing about the import export, sorry for the mess with the Excel. It was we lose some time during this stuff. It was unbelievable. I really didn't see it before. Like if one underscore could break all the code and break all the all the good job about it. The stuff I've already done before. Sorry for this. The last thing, sometimes could happen that you can have sometimes exotic files, let's say, for example, from some, let's say, other software, like, for example, Epi. For example, is an epidemiological software. It's used, I think it's used all around the world. It's kind of special software, like for some, for example, long time series in epidemiology. I think it's, for example, it would be very handy nowadays, you know, every one of us just interested in yeah, watching the COVID lines of number of occurrences per day or new occurrences per day, cumulative occurrences, you know. So people could do this stuff. Minitab is relatively old, but still old and gold kind of clickable, in both clickable and programmable statistical software. I think that nowadays it's commercially, you have to pay for using it. So maybe it's not so like not so great to pay for it. I don't know. I didn't work it. I haven't worked it without with it yet. So I don't know. But yeah, this is just the ancestor of our language. It was like, yeah, I guess it's very similar to R, but I think nowadays it's not so much developed. I think it's there is maybe a commercial version called S+, but over all the stuff which is around us as software is, I think, over just absolutely overwhelmed, overexceeded by our language and community of our language. And the SCSS, PSS, STAT, STAT, SysStat, WEC guys, for example, New Zealand statistical software, I think, or maybe, I don't know, yeah, maybe New Zealand. These are definitely commercial, clickable. WEC guys, I think both commercial and clickable. Commercial and it's not commercial. Sorry, it's not. It's for free. It's open source, but it's both clickable and programmable. For example, the SPSS is, I think, relatively widely used, and it could happen, for example, with some prefabricated data from SPSS. I have an example here, file from SPSS with a special suffix. The suffix SAV is the suffix for files which come through from SPSS. And for example, by accident, you can just handle with that. A prefabricated data set coming from SPSS, and you can do it just using a library called foreign, and its resource called read as one of its resources, resource functions read.spss and number of file, and it should be melted to our data frame. It's equal to true. So yeah, by setting this, we should get a well-known R data frame. So let's try it. I'm just going to check if my R session is able to see, yeah, a file from SPSS. Okay, so first thing, installation of foreign package. Still the same, package tab, install, and foreign. And foreign. If it's here or not, but it should work definitely. Foreign. Okay, sorry. More. Foreign. Okay. PSS. Let's take a look at this. I think it should work. Yeah, it's ready. We just use this some help. Yeah. Documentation, but I think that these two arguments are enough. So, yeah, from what and to which to data frame. So my data now. Okay, I'm going just to remove it to make sure that new version is going to read in my data. Yeah, I got something like a data frame from GSPSS. Yeah, the good, just a point about this is that if you got the SPSS file with the suffix SAF, we are not able to open it by nothing else except for the SPSS, original SPSS. Because you can see that if I'm going to try it, to open it by Notepad++, I'm going to absolutely fail here because I'm going into unprintable getting computer symbols and some. Yeah, there's something. The only part is which is just a SPSS data file of Microsoft Windows release. Okay, nice. But the rest is absolutely crippled. Yeah, you can see there are just unprintable symbols. And it's absolutely no meaning. So that's a really pity about this kind of file, because if we have no the original software, we are not able to open it. But fortunately, if we have R and we have foreign package, we can open it and we can also work with this kind of file. Yeah, you can see it works. Okay, so yeah, I got the other side, and definitely I'm going to take a look at the structure of this data. Yeah, it's just a data frame with some factor. It works. It absolutely works. So it's just a very handy package, and as you can see, it's able to read many formats from various software, from various services. Again, various originals. Well, so it was for data import and export. Yeah. Okay, we still have some time. I don't want to make this session too much long, but I can start with at least a bit of conditionals and maybe loops, because I think we started a bit later for today, and there was the unexpected delay with the outputting the data from our console to Microsoft Excel. But yeah, still we have maybe 15 minutes or something like this. So I think that we can start recording short loops. Sorry for this delay, and I'm sorry for this. Yeah, I was really think about the Excel. It was really unexpected for me. Well, so that okay, all the features like conditionals, loops, warnings, and errors, they are sometimes called flow control construct or flow controls attributes, something like this. And the conditionals are also conditional statements. There are several types of conditional statements. The basic one is called if statement, and you know it from, for example, also Microsoft Excel. It was just if statement, and if you know the syntax from Excel from practicals of medical informatics, you know it was just the syntax was just equal sign, if in upper cases, and then in the round case, in round brackets there were three arguments separated by, I guess, semicolons and check versions of, or check installation windows. And the first argument was just a logical, let's say, predicate, something like this, a logical condition, logical formula. The second argument was what should be output by the function when the logical formula, logical condition is true. And the last argument, the third one, also separated by semicolon, was the value which should be output by the function in case the logical condition is not true, when it is false. And this is like, yeah, this is like very similar, absolutely the same as the if statement in R, because it's just we have just dichotomic decision. It's just a decision construct or decision rule, decision function based on like a true values of the predicates of the, let's say logical conditions. And since we are using here in this course only two true value claiming some predicates, like it's sometimes called like Aristotle's logic, two values logic, or binary logic, or in Latin I have already told it to you, but it was just a in Latin tertium non datur. Tertium non datur in Latin means that there is no third option, any third option to be handled. It means that we have only two options, like true or false, either true or false, nothing else. And I also told you that this is not like a logic which is usually this is usually applied in computers, definitely science, like zeros and ones, of course. But in data science, sometimes there is a bit advanced logic applied, and I told you that it's logic with true, false, and not sure if true or false. It is the third option is we are not sure if the value is true or false. So this kind of mess or uncertainty could be handled also where this kind of true values tables, from high schools. And this is rather typical for data science because of the fact that in data science, if we have real data, many values are not, they are just missing. We don't know the exact values. And due to this fact, you usually have to handle them by this kind of uncertainty values. But now it's easier to understand that we have only two values, two true values logic, Aristotle's logic. And so there's now two logical states which could exist, either true or false, nothing else. Well, so sorry, this is not translated. Then check. It means like general syntax of if statement in R. Sorry, I will just correct it in the slides. It should be on GitHub. Well, so the general syntax is that if that in round brackets there is just a logical condition. Okay. And in parentheses, there is the first branch of this logic. It's pretty the same like it was an if statement in Excel, There was just a first argument, it was just logical formula, logical condition. Then there was a second argument, it was in fact an output of the function. Yeah. And in R it's just bounded by the first pair of parentheses. And this is somewhat a procedure, somewhat a procedure, which is done if and only if the logical condition from this round, bounded by this round brackets, done only if and only if the logical condition is true. And this part is optional. This is not necessary. Yeah, because in R we have more flexible code. We can have more. So this will be done if the logical condition is true. And also we can simply skip this or omit this. So it's not necessary to include this part of code because it's also could work. Yeah. There's a difference between Microsoft Excel's if statement where you were supposed to include three arguments. The last one stands for this branch, and it was not optional. It was like a faculty one. It has to be. Sorry, obligate one. Obligatory. It has to be fulfilled. It has to be insert the value which should be output when the logical formula was false. So this is not so much flexible like it was R, but in R, if we want to include this value, which should be output exactly when the logical formula is false, it could be done by this syntax else, and also the second pair of parentheses, and there is some procedure or value, which is output or returned, just in case the logical condition from here is false. Well, so examples, they are also in the code, so how it's work. So let's have a value of x, which is equal to 1. Okay. There is a version of if statement, and this is like the shorter version where there is no the second branch, no the second pair of parentheses for the value which will be output when this condition is false. Yeah. So this means that this command will be run only if and only if this logical formula, this logical condition is true. We know that for our value of x, so it's equal to 1, it is true. We can try to check it. And just select it in bold and press Control and Enter, and you can see it's true. So it means that it will be printed out to console that x is equal to 1. Yeah, so it works. You can see x is equal to 1. Just for comparison, let's try to change the value of x to 2. Oh my god, what is this? Okay, let's continue. Well, so now x is 2, yeah? X is, sorry, I didn't run it. Okay, now x is 2. So this is absolutely not true. This is false. So this is not going to be printed to console. As you can see, it was run, but nothing is printed. So it works. Or we can take a look at a bit different example where we implement also the second branch, the second pair of parentheses, where there is a value which is printed out to console, just in case that this logical formula is not true. So now x is true. Let's check it. X is true. So if x would be just 1, then x is, then this message will be printed like x is equal to 1. Otherwise, this message is printed to console. X is not equal to 1. So this is absolutely true. I want to say this is absolutely feasible as a meaningful. X is not equal to 1, yeah, because x was true. If x will be equal to 1, x is equal to 1, yeah. So it's as easy as this. Nothing too much difficult about this. The only thing is that some the only thing about this is there is some syntax about our if statement that we are supposed to like take a look at this and, for example, try to rewrite this these two examples just to to get some knowledge about it, just to get some feeling and some insight about how it works. Yeah. Okay. So. Well, so it was just for if statement. Yeah, I would just say that, yeah, since I called this conditionals, honestly, there are more than only if statement. For example, if you can see that, and this is also the reason why, for example, in particles of medical informatics, usually we got the case that, for example, if you remember this, there was just some kind of task that there were people, patients with their BMIs indices, and we wanted to classify them into different classes of kind of obesity or just habitus, you know, from internal medicine, BMI, and class of obesity, or just just classes of according to their weight, human body weight. So there's a class of normal weight, underweight, overweight, and obesity. And saying this, it's pretty clear that only one if statement couldn't be enough to handle classification into more than two classes here, because you can see that if you have this example, you can see that I'm able to decide based on the logical formula, which is usually here, you're always here in the bounded by the round brackets. I'm also decide or give two different outputs, but not more. But if statement, because if something, then either some other thing, some output, or some other output. Yeah. Only two possible. So usually, if we want to like to have more than two outputs, we have to make something which is called a nested or a hierarchical if statement. So, for example, this could be replaced by another if statement like this, for example. Yeah. And if, for example, if x is 2, then if we go to 2, and I can make a last else here. And this should be like something like, for example, x is neither 1 nor 2, because in case, oh my gosh, very strange today. It's our session. Well, because x could be either 1. In such a case, this message is printed out to the console. If not, if x is not equal to 1, then we are going here to this bunch of code. And once more, the R is asking if x is equal to 2, then R is going to output this message to the console, x is equal to 2. Still correct, still valid. But if this is also not true, it means that x is neither 1 nor 2, and R is going to print this message, the last message to console. It's definitely makes sense. So we can try that. I'm just going to run this. I'm going to go to modify. I'm going to take a 2, change it to 2. I'm going to get this message at the middle one. It will be, for example, 4, for example, or 3 or whatever. It's going to get the last message. It's neither 1 or 2. It's absolutely, I think, clear. And this is the way how we can get 3 different outputs. If I would like to have 4 different, I also have to change this last branch, which is then here for the the remaining case, or to new if statement, and so and so and so. I can give like in theory, I can get any number of any finite number of the output statements or the output messages, but yeah, why not? You can. But there is also other conditionals which are able to handle this kind of stuff in more general. For example, this was an if statement, and the other one is switch statement. Switch statement is something which is more appropriate, except to these cases. If you have more than 2 outputs and you would like to handle them not in this way by nesting another. So again, nesting of under and other cases, other and other if statements. You can handle it with switch statement, which is simple in linear form. Like, for example, if x is equal to something, then it's much more similar to something which is called dictionary in, for example, Python. You have something similar to list or vector, and you have pairs of keys column values. It means that if your, for example, in our case, if x is equal to something, then it's matched to appropriate keys, which is also For example, in our case, x is 4. Then key, which is of value 4, is found in my dictionary, and the value for because there are pairs of keys and values. So if I am able to match the key of a value 4, the appropriate value, so key is 4 and value is something, and the values could be, for example, this kind of pair. If value x is 1, then output is this. It works like this. So dictionaries in Python are much more closer to some which is called in our switch there, but this is not something which I would like to go into now. So those loops, this is also important. So I would like to make a quick tour through loops because I think it's important and I would like to do it now. Okay, so for loop, the basic one, if you're in just some kind of situation that you have to do a kind of procedure or just procedure of some kind or repeating of some code many times, and you know that the procedure or the code you are going to repeat many times is still the same or very, very similar to for each of the cases of the repetitions, you can use a for loop rather than copying your code many times below the previous code snippets, just to make the your code both more easier to follow, easier to read, and also a bit, let's say, smarter and maybe also quick, fast, usually easier to be executed for our console. So yeah, so how to do it? So we are going to do some examples, but there's also maybe kind of condition when to use for loop. If we know in advance that we are going to use the iteration by some limited time, and we know the number of repetition, number of iterations in advance, then for loop is absolutely the best way how to handle with this repetitions of code. Because if we are just going to use for loop, we are supposed to specify what is the number of repetitions. So generally, like I said, I'm going to use for as a dedicated word, referred word. Then in round bracket, there is a definition of my index space. For example, for some indices from 1 to something, 1 to 10, for example, or whatever. Or for example, for each, for example, value of, for example, English alphabet or whatever, things like this. And for each of this index of my index space, or for each, for example, placeholder of my vector, whatever, there is a procedure which is done for each such item, the index space, and that's the logic. So I'm able to repeat this procedure many times by definition, appropriate version of my index space, but I'm supposed to write the code for such a procedure only once here in my body of my for loop, and it should be bounded by parentheses. Well, that's it. So some examples to make the things a bit clearer. Okay, absolutely easy for loop. So dedicated reference word, round brackets, my index placeholder, like index I, typical situation. It means that for I in, there's also a reference word. So for word and invert are just the referred words of our language. So these should be used in this way, and it's not a good idea to change them, for example. Anyhow. So for I in vector of 1 to 5, you can see it 1 to 5 is just, 1 colon 5 can be read as 1 to 5, and these are equal to integer values of 1, 2, 3, 4, 5. So for each key in 1, 2, 3, 4, 5, do the procedure which is bounded by parentheses, and it's just like printing the index I into console. So nothing too much difficult, nothing too much interesting. It's not rocket science, but still something which could be good as a good illustration for loop. So let's try to run it. Yeah, and that's the output. I got printed number 1, 2, 3, 4, 5. In each case, it's just an index from the index page here. So yeah, this for loop is not so much useful, in fact. Yeah, but it does the job, and yeah. So this is the syntax. It's like something like a hello world of for looping. Well, okay. The next example is that I'm just going to use with vector letters. Another vector letters is not my defined letters, not like user defined letters, but vector letters is default inbuilt vector of R, and it means that it just these are just the lowercase letters of an English alphabet. So it's letters from A B C D to Z. Yeah, 26 values, character values of lowercase English letters. Well, so I'm just going to iterate. So I would say that this for loop is sometimes closer to some VS Code for each loop, yeah. But forget on this; it's absolutely the same logic. It's another kind of for loop. So my letter is an index. There could be, for example, I or X, whatever you want to. But I just prefer to use my letter. It's just a placeholder. It means that first let's run for A, then for B, then for C, and so on till Z. So if I for example at the first iteration is for loop, then my letter will be equal to A, lowercase a. So first letter in English alphabet. And what is done with this stuff? So it's printed to console. But what? Paste. You know that function paste is used to concatenate parts of text or parts of words or sentences into one sentence by a defined separator. The separator here is just simply a gap or space. Just one space. So I'm just going to paste my letter, so A, B, C, D, and so on, with this kind of sentence, or yeah, this is a short sentence, is fine. Why not? And separated by one space. Okay, so the expected output is that I will just get A is fine, B is fine, C is fine, D is fine, and so on. And after 26 times, I will get just Z is fine. I run it, and that's the output. So it works. A is fine, B is fine, C, and so on and so on. So this is the output of this for cycle. So the logic, as you can see here and here, the logic is that I would like to do something, and definitely I am more than sure that no one of you would be just glad to do something like this manually, like A is fine, okay, B is fine, okay, C is fine, okay, okay, it's fine, okay. I have to do it, in fact, in total 26 times, so really bad stuff. Now I'm just not talking about the thing like if this is useful, so like in fact it may be not so much, it's an illustration, but the logic is that that there are exactly 26 outputs done automatically. It was in maybe 1 second, printed out in 1 second, maybe maybe in shorter time in 1 second, and by a relatively simple code. But if you are supposed to do it manually, then yeah, good luck. Enjoy it. Yeah, this is absolutely there will be absolutely boring stuff to do it, like including the fact it's not so much useful. But yeah, you know. So the for loop is exactly for this kind of task. If you have something which should be repeated within the same, for example, framework or with a very similar procedure, and only for example, only one of the attribute features changing, and we are able to define or just to exactly, let's say, indicate what is the change. In this case, it's just a change of the letters. In the first case, it was just changing of the indices which were printed out the console, and we are able to define very exactly how is the placeholder in my index space changing. This was the last like index I within the first 5 integers, and this is like my letter, just my letter placeholder. So in just lowercase English letters. Well, so this was for loop. While loop. While loop is something very similar to for loop, but there are some differences. So while loop is if you also have something, some start, some procedure or some stuff which will be done many times. So we are supposing to do it repeatedly, and you don't want to do it manually. It's a good approach. Programmatically say it's a very good approach. So it should be done many times, or more than one time. And the difference between a for loop and a while loop is that whereas you know a number of iterations or number of iterations in the case of for loop in advance, by using while loop, you are not supposed to know it. For example, you don't know it in advance what will be the number of iterations. Yeah, or at least, for example, sometimes you can realize you can do some algebra or some mathematical results to realize what is the final number of operations or iteration. But if you don't want to handle this, don't worry about it while it's going to do it without any or result or any or inspections. What is the final number of iterations? So yeah, this is like very similar to for loop, but the difference is that you don't know, you are not supposed to know in advance what is the final number of all the iterations, or final number of, for example, how many times the for loop will be repeated. In for loop, it was pretty exact in both, pretty clear in both the cases. In the first cases, okay, we know the number of iterations was exactly 5. In the second case, also, we know that if there are exactly 26 letters, like, you know, I'm going to take a look at this line. I'm sorry, line. Yeah, line 26 letters, you know. So it's the number of iterations in this case is also known in advance 26 times. Well, yeah. So general is that I have to treat my index space. Yeah. So at the very beginning, since R is language, it starts to number all the vectors and all the structures from 1, not from 0, as Python does, for example. I have to define my index and set it equal to 1. Then there is a word which is equal to while. A logical condition is bounded by around brackets, and while the logical condition is true, then the while cycle is while a loop is going around and it's going to be repeated until the logical condition is still true. So there's a procedure in parentheses which is going to be repeated until the logical condition is true. And so the procedure is done for each index. It can modify the logical condition. It's expected to modify it sometimes in the future, because in case that the procedures are repeated many times, still repeated, and the index is still growing, and there is absolutely no chance that the logical condition is going to be touched by the procedure, and it's going to be still true, then we are absolutely going to have an infinite loop, which is going to be end like by our console after some time, by some inspection, if there's a possibility of to be terminated by itself. But yeah, this is not like the way we would like to have. So there's like a hidden assumption that the procedure, there will be just time point in the future after. It doesn't matter if after many times of iterations or after how many times, but after some times of iteration, the procedure which is run within each of the iteration is going to change the logical value from true to false, just in order to stop the while loop. And the last thing is that you have to increase your index manually, because you have to initialize it here manually, and you have to increase manually, because while it's only doing the procedure if this is true. So you have to change the value of index manually by this row code, line of code. The problem is if you forget to do this, then you are also getting in some trouble, because by not changing the index means that if the for index 1, if the procedure is going to be run and it's not going to change logic to true, then it's going to be repeated still for the values of values associated to index of number 1 is going to be repeated many times, and it's clear to realize that it's going to be with infinite, not infinite times, because absolutely no reason how to beat stuff, because if the procedure for the values of index 1 is still going to be same, because index is not going to be growing, they are going to get infinite loop. So that's it. Some examples. The example is going to do exactly the same stuff like it was in a for loop part, but using a while syntax. So I'm initializing my index I to be set 1 as 1. So while try to take a look what is the logical formula here, logical condition. If the I is lower than or equal to 5, then do something. Okay? And it sounds feasible, because if the I is lower than or equal to 5, and I would like to print the I to console, then I can suppose that I is going to be printed until it is 5. If it's going to be 6, then it's going to be stopped. So if I is equal to 1, this is true. While loop is going to print number 1 to console, is going to increase the index I by 1, so assign it to itself. So this is 1 plus 1 is 2, assigned to I. So now I is 2. We are going to the beginning of a while. So 2 is lower than or equal to 5. It's true. So print 2 to console. 2 plus 1 is 3. I is from this moment 3. Okay, let's go to the beginning of a while. 3 is lower than or equal to 5. It's true. Print 3. 3 plus 1 is 4. 4 is equal to I is equal to 4 now. Let's go to the beginning of while loop. 4 is still lower than or equal to 5. Print 4. 4 plus 1 is 5. I is equal to 5. So 5 is equal to 5. So it still holds. It's still true. Print 5. 5 plus 1 is 6. I is equal to 6. Let's go to beginning of while loop. 6 is not lower than or equal to 5. So now it is going to be false, and we are going to stop this while loop. So let's run it. We go to printing of the first 5 integers. I is, as I told you, now 6, because the first value is going to terminate the while loop. And yeah, I think that's the only thing which could be inspected by this file. I think it's pretty clear. So still relatively easy syntax, but I would say that in such a case that we know that we are interested only in, from some reason, it's some kind of baby step, but we are interested in printing the first 5 integers in console. Then from my perspective, for loop is easier to be handled, because you can see how easy it is. Then while because there is additional stuff you have to handle with, like the managing and treating of these indices, and realizing what is the appropriate condition, logical condition. Okay, why not? Both of these approaches work. The second, case is okay. Maybe one more from my side. I would say that in data science, usually, since we use the time finite data, different data frames, different data sets, so on. usually we are able to realize in advance what is the number of repetitions. So absolutely, I think that almost in each cases of some data manipulating or data wrangling, we are using for loop if it's needed, not while loops or, for example, repeat until loops. So while loop is for data science maybe just the only one really important from this portfolio of loops. But I would say that maybe this is not what we are going to talk about now, but I would say that there are also some possibilities how to replace for loops by apply functions. It's here, yeah, but I think that we are going to do it for the next session. So just for loop, and the second case for loop. Okay, let's try to realize, or let's try to assume that I don't know how many letters is an English alphabet. Yeah, let's try to assume this. So I would like to do the printing of the short sentences like A is fine, B is fine, following the while fashion, not the for loop fashion. While I would prefer while in this case, and the logic is a bit different. And what I'm going to do, so firstly, you can see it. I'm just going to save the constant, just the vector abundance, constant, which is called letters, lowercase English letters, to my vector, my letters. Yeah. Yeah. Let's run this command. And my letters are also like A, B, C, D to Z. Yeah. I'm sorry. I'm sorry. I'm just repeat until. Sorry, taking back. This is what I'm going to talk about a bit later. Sorry, I'm here. While so, but still the same interaction. So letters. I'm just assigning the letters to my letters. Okay. My letters. It looks like this. Okay. So the logic of this while loop is that I would like to. I'm just asking at the beginning of each iteration of while loop if the length of my letters is larger than 0. In other words, it means that there is still some letters in my letters vector. If yes, if there are still some letters, one or more in my vector, my letters, then the procedure in parentheses is going to be run. Yeah. So how it works in the procedure and the parentheses. So I'm going to print the paste, and each time I'm just taking the first letter of my vector, my letters, yeah, and I'm just going to concatenate it by paste function with a short, like this predicate of the sentence by separator as an empty or one space, paste it to the console, so print it to the console, and this is important, I'm just going to, the minus notation vectors. It means that I'm just going to put the first item of my vector, my letters, and I'm going to remove it. I'm going to remove it because if there will be just without a minus, it will be just addressing. It will be A, the first letter, but with -1, you're just removing the first element. So it's just B, C, D to Z. B, C, D to Z. Well, so I'm just going to replace my letters by a shortened version of my letters, which is shortened by removing the first element, the first letter. Because the first letter was already printed out the console in the same iteration, yeah, 2 lines above. So how does it work? In the beginning, we have exactly 26 letters of English alphabet. So this is like 26. Length of my English alphabet is 26, so it's larger than 0. I'm just going to paste my letters. The first element is A, so A is fine. And my letters minus the first element is just the vector base, B, C, D, E, F, G, and so on to Z, which is going to be saved as my letters. So the length of my letters now is 25 because there is no A letter. So I'm going to beginning of a while loop. There is length of my letters, which is 25 now, still much larger than 0. So it's going to run the procedure here. Then print, paste. My letters, and the first element is now not A because A was removed during the previous run, previous iteration, but the first letter now is the B. So B is fine. Yeah, B is fine. It's now printed out to console. And at the last line, I'm just going to remove the first element, which is now B. So I'm going to get a vector of C, D, E, F, and so to Z. So my letters is now a vector of length 24. So I'm going to beginning of the while loop. 24 is still larger, much longer than 0. So there are still many letters there. So let's begin the procedure. Print, paste. The first letter now of this modified my letters vector is C. C is fine, and my letters -1 is it means that I'm just going to remove C. So I have the vector like D, E, F, G, and so on assigned to my letters. Okay, now the length of my letters is 23, and so on. So this is like repeat so much time until the my letters is my letter consists only of one letter Z, but length of one letter is still 1. 1 is larger than 0. So print, paste, my letters 1. If there is only one vector, one letter in my letter, so it means that it's the first. So this value is the first one, and so Z is the first one. So Z is fine, it's printed. My letters minus the first value is now an empty vector. So my letters is to my letters is assigned an empty vector because the last letter which was here was the Z, but by this notation it was removed. So my letter is now an empty vector. Let's go to the beginning. And empty vector, length of empty vector is 0, but 0 is not larger than 0. Yeah. It means that this is like the first time point where the logical condition in our while loop is going to be false, and it's pretty the time point when it's going to be stopped. So this is the logic. So at the beginning, so you know now why how this while loop works. It works. A is fine, B is fine, C is fine, so on to Z is fine. So now the length of this letter is absolutely 0. There are no letters. Yeah, it means that it was the character vector, but there are no letters here. Its length is not 0. Yeah. So it works absolutely in the way we have expected before. Okay, so yeah, so this is while loop. But also, from my perspective, if you compare this while loop, which does exactly the same stuff like this for loop, I think that we all agree that the for loop approach is in this case easier because maybe you have to realize what is here the stopping condition or just logical condition that you have to handle your index space by this kind of like removing a parser vector and so on and so on. Yeah. So I think that the for loop is a bit easier to understand. And repeat until loop is also the last loop you should know about. It's very similar to while loop, very. Also, it's much similar that it uses the same syntax, but the semantic is a bit different. So how does it work? So semantic, the logic when to use the repeat until loop is absolutely the same as we for example when we should use our while loop. So while loop and repeat until are in this manner equivalents. So there is there is a bit different. There are slightly different, yeah, slightly bit different. So let's go to the general syntax. So at the beginning, I'm just initializing my index while true. Let's take a look at this. If the conditional logical condition here is true, but you know that true is true absolutely all the times. Yeah, all the times is true. True is still true. True is just always true. Then it's pretty easy to understand that this while loop is infinite loop. But there is something like an exception from this. Okay, this while loop is absolutely 100%. We can be absolutely 100% it is infinite loop. Yes, it is. But there is a stopping condition, which is using a if statement. And if this is going to be true, it's going to express this command. And this is a dedicated word similar to if, while, or for, or whatever. And it means that it's absolutely stopping the running of all current loops and going after the last parenthesis, yeah, after the last body of the last looping. So this is the okay. Maybe I would say that the repeat until logic use this kind of stopping rule, which is in while loop moved to this conditional, yeah, to this logical condition. This is the only maybe difference. Still, there's some procedure which should be done for each index until the stopping condition is not generated. Sometimes at some time point, the procedure which is iterated here should generate the stopping condition, because without this generation of stopping condition, it will be run, so many times it will be run infinite time. And also, we have to increase our index by 1 at each point, at each iteration. So some examples, still the same. We would like to print out the first 5 integers to our console. So the first index is 1, then while true. This is true for all the time, but we are just going to increase our index I by 1 per each iteration. So in case that I is equal to 6, we have to stop this loop. So we have to tell R that in such a case, if I is equal to 6, let's break this rule and go with your interpreter here after the last parenthesis, just to, for example, continue with some other code, but just stop this while loop. It's in fact a repeat until loop, yeah, but syntactically set just a while loop. Meanwhile, it's just all the indexes are printed out to console, and indexes are increased by 1 per each iteration. So it means that after the running of this loop, it's more than clear that I is equal to 6. So it works. It works for I equal to 1, 2, 3, 4, 5, and 1 is 5. Now it's 5 plus 1 is 6. I is equal to 6. Let's go to the beginning. While true is true, so I'm just proceeding here, or the interpreter is proceeding here. 6 is equal to 6. Oh, it means that now it's this condition is fulfilled. This one is now true. So we are moving here. Break. We have to break the loop, and we are going here after the loop. So by running it, yeah, it works. Yeah. And I is now equal to 6, because it was the first time point when it's not the first, it's just exactly the time point when it stopped. Okay, and example with the letters. I'm just using the letters. I'm going to set it to my letters. While true, this will be true for ages. If line of my letters is equal to 0, it means that the vector of my letters includes no letters. It means that there is nothing what could be printed out the console. Then let's break this repeat until loop. But if it is not satisfied, let's continue to printing my letters is fine to console, and removing the first letter, which was just a second ago printed to console, from the vector, and reassigning this shortened vector to my new vector, to my letters. Yeah, let's go to beginning of the while we are here. True is true, so let's proceed here. In the line numbers is still positive, so there are some letters in my vector my letters. Then it means that we are not breaking this loop, and we'll continue back, or continue below to printing the appropriate the first letter from my vectors to console with the suffix of is fine. So at the very beginning, my letter is also an empty vector. So let's try to run it. So we can see it works. And my letters is now at this moment absolutely empty letter with no letters. Absolute vector with no letters. Yeah. So it was for repeat until. I would maybe like to say, say a few words about warnings and errors. Absolutely last step for today. Warnings. Warnings is just text messages returned by either a function or procedure to a console, but it means it's just a message which could help you, just to inform you as an end user that there was something unexpected or something unusual during running either the function or procedure. But it wasn't such a big problem, if I'm just going to say it in more layman words, layman terms. This problem was not so much significant for the interpreting of the code. Such that the code could be it could be finished. Yeah, the code was finished, execution of the code was finished, but still there was something which wasn't so much expected by R, or something which you as an end user should be aware of. So as an example, as I told you, it's not a malicious error, it's just a warning. It means that the code is executed like till its expected end, and you are going to get your results, but it may happen that results are a bit different in some cases. For example, because there was, as I told you, there was something unexpected, for example, during the running code, based on combination of some values or some operations applied to some values where, for example, not so much legal and so on and so on. So my days, the code usually runs to its end, like successful, let's say, but there are some warnings that something was run a little bit different than it could be expected at the very beginning. So, as an example, logarithm of -5. You know that logarithm of negative values are not defined. If we are trying to remember how it was calculated to your high school maths, I presume that you went to study to medicine just to avoid this kind of math, but I still get you know that logarithms of negative values are not defined pretty easy, because we know that if you try to find a basis which are going to expose to whatever value, to positive or 0 to negative, regardless of this, still we are getting a positive value. So there's no absolutely way how to get a negative value, regardless of the fact what the basis is. So it couldn't be defined. And R knows this. R is really good at mathematics here. So the reason is, the result is that we got not a number value, no the special value, NaN, it means not a number value, not a number, because that's absolutely correct, because this is not a number. This is not defined. This is like a mathematical conceptual error, how to say it, the error of kind not defined in mathematics, even in like college mathematics. So not a number is appropriate. So it means that if we have, for example, I would say maybe like this: if we have logarithm of some vector 1, 2, 3, you can get the results. But okay, this is what I would like to show you. I would like to get logarithms of these for numbers. So 1, 2, -3, and 4. Absolutely, you know that logarithm of 1 is 0, because this is just a natural logarithm. So Euler constant powered to 0 is 1. And these are some results, but you can see that for the third value, since it's negative, you can see that it was output as an NaN, not a number. But still, the last value, which was calculated after this one, producing the warning message, it's still calculated, still enumerated. So it means that, as I told you, all the calculations are done. Okay, there was a problem because elevators of minus negative value is not defined well. So there's a warning message, and there's a message like, and then it's what produced. Okay, absolutely understand. And the results are here. These three results are not touched by this warning, or by this warning message. And the reason that there is warning message is just an ANM value. So this is the problem. But you can see that the calculation itself just run, and you go to your results. Yeah, perfect. So this is like a warning. This is warning. Warning is, in fact, your good friend in R, because the warning message usually helps you to realize that there's something, for example, which is almost correct, but almost. Yeah, there is something what could be done even better. So in such a case, for example, you can, for example, do a if statement before this, and if statement, or in other words, for statement and for loop, and asking in each iteration for loop if the value is larger than 0. If yes, then calculate logarithm of it. If no, skip it. So there will be just, the logic would be something like, you know, or say x in this vector. Yeah. So if x is positive, then calculate logarithm of x, and for example print it out maybe. So let's print it out to console. So we can do it, for example, this way. And we got the 3 results without any warning because we skipped this value. So this is, for example, the way how it can be improved a bit, not to give the warning. But warning is not a malignant error. It still runs to its expected end and give you the results. Okay, we can also, as end users, make our own warnings, warning messages. I just try to do this kind of function, like my function. This is something which I'm going to talk about a bit more in the next session, but it's like the way how our user-defined function could be done. So name of the function, get my algorithm. Name of the function, equal sign or oriented arrow. Function is a referred word which will be changed anyhow. X is our argument, just a number. This is like, let's say, a comment what this function is going to do. It returns a natural value of a number x. If x is negative or 0, then cat is very similar to print, but it's a bit better formatted. Cat, x is non-positive, so it means it's 0 or negative, and it will be output. And this stands for a new line, you know. So this is going to be printed to your console, and the way how I prefer this is, for example, that in this warning message, there are usually some technical, this is usually some text speak, yeah. It's usually technical spoken, or too much engineering, let's say, all these warnings. So sometimes it's better to make, for example, better warning messages which have, for example, which let's say a beginner users are more familiar with, something like this. This could be a reason. So I'm just going to treat the warning like this, and of course, if this is not true, I would like to return the value. I can still calculate the value even if the x is lower than or equal to 0, but I have to suppress any warnings which would come from the function log itself, because this would be this kind of values, like the technically spoken, too much technically. So suppress warnings is a function which can suppress all the warnings from inbuilt functions. Yeah, so it should work. So it calculates the logs, returns logs, but without any inbuilt warnings, but with my possible warnings. So I'm going to just going to express this or execute this chunk of code. So now R is able to run this function. I can just try to check it. Okay, you can see there's the code of my function and how to use inbuilt user-defined function. I just going to use get my log with some usable values, like for example 10. We're going to something like, I don't know, 2 to something. Yeah, 2.3. It works. It's simply absolutely the same like because there's no reason to get any warnings. But if I now try just to make comparison, log of -5 was just this. Yeah, the technically spoken warning message. But in my case, I got the same value, not a number. And the warning message is my warning message. You can see X is non-positive and I will be output. Which is like, for example, more informative because I know that, okay, the problem is that my X is, for some reason, negative. So it's non-positive. And that's the reason why the function is outputting NaN, not a number value, because okay, I'm just calculating algorithms. I cannot use negative values as inputs for algorithm. So that's the reason. Yeah, it's more for example informative. So that's a sometimes could be handy if we are going to define your own functions, which is definitely very useful, and I'm going to talk about it next week. Is the way how to do it. And the last thing I would like to do for today is errors. Because apply family function, we will do the last time to do it. Warnings and errors. Okay, the errors part. The last slide and the last thing I'd like to know to tell you something about. Well, so what is error? Error is when you is also a text message which is returned by a function or a procedure when there is an executed problem when it occurs. But this problem is so much significant, so much important, or so much so much significant during the execution of code that it cannot allow to execute any other part of the codes after the let's say time or the time point when this execution is occurred. It means, sorry, it means there is absolutely no way how R is able to overcome this problem or treat it, for example, with returning of some special values like not a number or not available number. And there's like it's so much important problem for the execution of code that R is not able to overcome it anyhow. It means it has to stop the execution and give you the error message, and it means for you that okay, I have a problem because I have to fix this error or fix the problem which tends to do to make the error, and after it, not earlier, after it, I can start to run the code or the chunk of code to run it, and hopefully without any more error. So there is an example. You can see it by a naked eye because since we as humans are able to understand it, I just wanted to make a summation of 1 plus 1. If I'm going to handle them as the numbers, I'm going to my output and I can see that it's like correct with applying of some basic arithmetics. But if I just bound it the first and the second, the first or the second would be enough. Bounded by double quotes, it means that I just made these values not like a numeric values but characters, yeah, then it's such a problem for R that this summation couldn't be run. You can see error in one swap or double quotes. Non-numerical argument is was applied to binary operations. It means that uh, yeah, we as humans are able to make the summation maybe, but R is thinking about these values as characters. It means like words or letters, and you know that R is not distinguishing between the fact if it is just in fact a number or a letter or some other alphanumerical character string. Simply, it's a string or it's character, so it's not appropriate to make an estimation that are arithmetical operations with it. So error is outputted. Yeah. And if I in case that I would like to treat, for example, some of this risky situation, for example, when I have just defined my own functions. In this case, I just defined my own, which is called sum up the squares, is equal to a function with arguments a and b, two arguments as inputs, a and b. These are supposed to be numbers. The function definition is one more time: name equals sign, referred name label to function. This should be changed now. Round brackets and all the needed arguments to give the appropriate value function are stored here and separated by commas. And the last part this is called function body, and is function head, and it's called function body. I will talk about it during the next week, but like a very good introduction to user-defined function. In a parenthesis, there is just a function body, and all the procedural calculations should be stored there. So there is a quick comment like it returns the sum of squares of numbers a and b. Okay, you can see it here, yeah? A squared plus b squared. But the interesting stuff is going to make a bit clear. So interesting stuff is on these two lines. Like this is like if statement, and the condition here if a is numeric. If a is numeric, that's okay, but you can see there is an exclamation sign before it. It means that if a is not a numeric, if it's not a number, for example, if it's a character, or if it's a logical value, or if it's an NA value or NaN value, then we would have a problem by this calculation, because we can do this calculation only with a number, numerical or maybe integer value, but rather numerical. So if it's not a numerical value, we have to stop the calculations even before running this. So I can use inbuilt function stop, which is used for this purposes. Here after a statement, there is a parenthesis part. What to do now is a stop function. A must be a number. Yeah, this is what will be output to end user to make him like a hint that okay, you are very likely using something which is not a number, and you would like to have a sum of squares of your input. So think twice if we are using in fact number or in fact numbers. The same for B. If B is numeric, that would be okay, but if B is not a numeric, there's an exclamation sign before it, then stop the function right at this moment and return to end user this error message like B must be a number, and don't do this calculation. So, but if both of these lines are executed properly, it means that this is false and this is false. It means that if this is false, it means that this is true, so A is numeric. And if this is false, so this is not executed, it means that this is true and B is numeric. So both A and B is numeric, both A and B are numbers. So it's easy to calculate A squared plus B squared and return to the end user as an output of this function. So let's run the function Okay, now the running function, your undefined function means selecting all the appropriate code from the beginning to the end like this, pressing Control Enter, like telling R that, okay, this is my function, which is called sum of the squares, and it works like this. You should know about it, R. And now I can try to execute it. The execution function is that my function is just it's still the same, like it would be just like an execution of a inbuilt function. So the name of the function, in this case, this is just my function, which I define here. And in around brackets, they are all important input arguments, A and B. You can see that this is A is equal to 1, B is equal to 2. So by the logic here, both 1 and 2 are numbers. 1 squared is 1 plus B squared. So 1 squared plus 2 squared is 1 plus 4 is 5. And yeah, I got 5. It works. But in this second case, you can see that there is just something a bit fishy, because you can see that A is still a number. It should work. It could work. But 2 is not a number. Now this is like treated like a character to make it clear. Yeah, you can see it's just a character, of course, and it couldn't be summed or squared. And you can see that I got my error message. B must be a number. This is exactly my error message. B must be a number. This is what I got. Okay, error in, this is something which I'm not able to change anyhow, because this is like a primitive R, like primitive R messages. Error in something. This is something which couldn't be, okay, it could be changed, but not within this course. Yeah, but this is like a message for end user after the colon. B must be a number, because before it, if you know it, I tried something like similar like this, or an experiment. If I'm going to knock out my error messages and I'm going to use only this functionality, let's take a look what will work about. This will still work out because 1 and 2 are numbers, but this is going to return the original default R error message, that non-numeric argument to binary. This is maybe not so much clear what is in fact the problem. Where is the problem? What should I make a different, or what should I as an end user make different to just to remove this error, just to avoid this error, to make the things work smoothly. Because it's like very technical speaking. Non-numeric argument to binary operator are the operators which are in this manner. This operator plus and there is a there is just a value before it and after it. Like this. So yeah, this is a very technical speaking what is this kind of error. So if we are the author of function, and for example, you are going to share, for example, with your team in the laboratory or whatever, it's better to make maybe more human readable error messages like this. So one more time. I'm going to, so this works, and here I got my, I got this stuff, I got this error message, which is exactly what I would like to do. Yeah, I got this, nothing a number. It's much more clear what I have to change. I by mistake, for example, used quotes instead of not to use them. Now it works. Yeah. So this is the logic. Okay, apply functions. Not now. It is interesting, but not maybe so much for this course. Logic of apply family functions is that you can do the same better. Okay, you can do the better. You can do the things in R such that they will work. Yeah, they work. They do the stuff. This is like the level 1 beginner level, let's say. And the level 2, there are many levels, but the next level is that you can do the things that which work, and they work effectively. And this is apply family is one of the way how to start to do the things that are effective, how to do it, how to do stuff, for example, fast enough, how to, for example, speed up your code in some bottleneck parts or things like this. But I'm not, I think that this is not like something which would be appropriate for Friday evening. I'm the only one here, but still there's a Friday evening. So it, for me, it's also Friday evening. So I'm going to maybe make some conclusion, big conclusion, or big, or let's say quick maybe insight or something like this into apply family functions during the next week or at the beginning of next week. We'll see how the other things will go. Well, so this is I think everything for today. I'm going to finish this session. I will try to do the render of this recording. So sorry for this stuff. Sorry for the mess and the confusion about the outputting of objects to a Microsoft Excel. This was like unexpected for me that there was just this kind of straight behavior of underscores in names, because as you could see, there was just in the Czech version of this course, our output has maybe 4 underscores and it works. If there was 1 underscore, I don't know why, but it doesn't work. Okay, but but the conclusion about it is that rather don't use underscores in your names or when we are trying to output our objects to Excel files to your local drive. It seems that it works better without any underscores. Well, so that's it, guys. You know my email if there are any comments or questions regarding today's session. You know the GitHub link, and I will email you by the links of the rendering, and maybe I'll just make a email, let's say, with the links to all the stuff, all the code, slides, and recordings of this first week of the teaching of this logic art subject. Okay, so have a nice weekend, and we can go on next week. Okay, so have a nice Friday evening and have a nice weekend. So bye bye.